The screen opens in darkness, an ocean of silence so complete that even the thought of sound feels impossible. Imagine the cosmos not as the vast expanse we know today, filled with glittering galaxies and whirling stars, but as an almost breathless void, a place where time itself had not yet learned how to move. In this silence, something waits, though we do not yet know what. The imagination trembles here, in this impossible stillness, because our minds are built to think in beginnings and endings, yet what comes before a beginning? As the camera drifts through the black, faint points of light begin to appear, stars folding inward, collapsing in reverse. Supernovas implode back into themselves, galaxies unravel into clouds of invisible matter, and all the scaffolding of creation begins to retreat. The universe does not expand. It contracts, as if everything we have ever known, mountains, oceans, cities, the memory of every heartbeat, was only the faint echo of something much older, now flowing backwards into silence. We are being carried toward the edge of the ultimate question, the one that has haunted both scientists and philosophers. Was the Big Bang truly the beginning, or merely the latest verse in a poem that stretches back before time itself? Could there have been a civilization that lived before our universe? One so vast, so unrecognizable, that its very existence would shatter our understanding of reality? The thought is unsettling yet magnetic. On one hand, we cling to the comfort of beginnings. Every story we know starts somewhere: the birth of a child, the founding of a city, the ignition of a star. But what if the universe itself is a story without a first page? What if there were pages before ours, burned away, leaving only whispers, fragments, a hidden residue we cannot yet decipher? The image sharpens. Endless deserts of frozen starlight stretch out before us, then collapse inward as if drawn into a single point. Scientists call it a singularity, a place where all laws break down, where space and time dissolve. But perhaps that word conceals more than it reveals. A singularity is not simply a wall, an end beyond which there is nothing. It might also be a bridge, a doorway. And if it is a doorway, then who or what might have passed through it long before we arrived? It is here, in this space between awe and dread, that the imagination falters. To picture a civilization before the Big Bang is to question not only the origin of everything we know, but also the destiny of everything we will become. Such a civilization would not be bound by time. It would not measure itself in centuries or millennia. It might stretch across billions of years, or it might transcend time entirely, existing in a realm where beginnings and endings mean nothing. The very word civilization may not apply. We call it that only because our minds need familiar language, but what it truly was could be something beyond comprehension, something that looks less like a city and more like a cosmic field of thought, woven into the fabric of reality itself. The silence deepens. And then, almost imperceptibly, we hear it, a sound, faint and distant, like the echo of a bell ringing in another room. It is the whisper of something that should not exist, a trace of memory carried across impossible gulfs. Could this be the residue of a lost civilization, encoded not in stone or metal, but in the very structure of space-time? The background radiation of the cosmos still hums faintly, and some wonder whether it contains more than just random noise. Could it be, in its strange texture, the fingerprint of a universe before ours, a message carved into the bones of reality itself? The question is overwhelming. If a civilization truly existed before the Big Bang, what became of it? Did it vanish in the collapse of a universe? Did it pass through the singularity to plant the seeds of another cosmos? Or is it still here, in ways we cannot yet perceive, its presence stitched invisibly into the laws of physics, quietly shaping every atom, every star, every thought we have ever known? And yet, the unsettling possibility remains that we will never know. Perhaps the greatest truths of existence lie permanently out of reach, just beyond the veil. Perhaps all that survives are the faintest shadows, like the glow of a candle long extinguished. But it is this very mystery that draws us forward, that keeps us searching. For to imagine that something came before is to imagine that our story is not alone, that our universe is not the only stage upon which existence plays out. The screen fades again to black. Silence returns. Only the echo remains, a reminder of the fragile line between what we know and what lies forever hidden. And yet, in that silence, another thought takes root, a dangerous, exhilarating thought. If civilizations have risen before the dawn of time itself, then perhaps time will not be the end of us either. Perhaps, in ways we cannot yet see, we too are part of a story that does not begin with the Big Bang and will not end with the collapse of stars. And so the question lingers, suspended in darkness, vast and unyielding. What if the civilization that came before the Big Bang is not gone at all, but waiting, patient, watching, hidden in the echoes that ripple through eternity? In the beginning, there was no sunrise, no space to stretch into, no ticking of any clock. There was only a storm of nothing, a place where words like before and after meant nothing at all. And then, in an instant so brief it cannot be measured, everything that would ever exist was born. Not quietly, not gently, but with a violence so absolute that the very concept of time erupted with it. This is the story we call the Big Bang, the birth of time itself. Imagine a darkness so complete that even the thought of light is absurd. In that abyss, smaller than a grain of dust, compressed beyond comprehension, all the energy of countless galaxies is waiting, trembling. It is a cosmic seed, heavy with potential, bursting at the edge of inevitability. And then, it happens. A spark, not of fire, but of being. In less than a fraction of a second, that seed expands, inflates, surges outward with inconceivable force. Time begins its endless march, and the universe unfurls like a great canvas stretched across nothingness. The first instant is chaos, a furnace beyond imagination. Temperatures soar to trillions of degrees, so intense that atoms cannot exist. Matter and energy swirl together in a searing haze, particles flickering in and out of existence faster than the blink of thought. The laws of physics themselves, those invisible threads that hold reality together, are being written as the storm rages. Gravity takes its place, binding mass to mass. Electromagnetism sparks into order. The weak and strong nuclear forces ignite, locking particles into their endless dance. These are not just forces, they are the scaffolding of existence, the unseen architecture upon which every planet, every ocean, every living being will one day rest. As the universe expands, it begins to cool. A millionth of a second passes, to us, meaningless, but for the cosmos, an eternity of transformation. Quarks, the tiny fragments of matter, link together to form protons and neutrons. Soon after, in the first minutes, nuclei are forged, hydrogen and helium, born in a cosmic forge that dwarfs the heart of any star. This is nucleosynthesis, the first chemistry of the universe, and though the cosmos is still wild and unrecognizable, the seeds of all future matter now exist. But light cannot yet travel freely. For hundreds of thousands of years, the universe is a thick, opaque soup. Photons are trapped, bouncing endlessly, unable to escape the density of matter around them. Imagine standing inside the brightest fire imaginable, yet seeing nothing at all, only blinding fog. This was the young universe, brilliant yet hidden from view. Only patience and expansion would bring clarity. 380,000 years after the first spark, the fog begins to lift. The universe cools enough for electrons to bind with nuclei, forming stable atoms. At last, light is free. It surges outward, carrying with it the first visible signature of creation. This faint glow, stretched thin over billions of years, is what we now call the cosmic microwave background, the oldest light in the universe, a silent photograph of the birth of time itself. It still hums around us everywhere, whispering of that ancient moment when darkness first broke. It is easy to believe this is the end of the story, the universe born, expanding, filled with light. But in truth, it is only the opening note. Over millions of years, gravity begins to sculpt. Tiny fluctuations in that background light, little ripples of density, begin to grow. Clouds of hydrogen collapse, stars ignite, and the first galaxies bloom like flowers across the dark. The canvas of space is no longer blank. It is a masterpiece of fire and motion, billions of suns blazing against the endless night. From these stars, heavier elements are forged. In their burning hearts, carbon, oxygen, and iron are born. When the most massive of them explode, they scatter these ingredients into the void, sewing the cosmos with the building blocks of life. The story of the universe is not only one of expansion, but of transformation, of raw chaos gradually sculpting itself into order, and order eventually into the possibility of awareness. Out of a singular explosion came the faint potential that one day, eyes would open and look back at the stars, asking where it all began. And yet, even as science paints this breathtaking picture, questions remain. What ignited the spark? Why did the cosmic seed exist at all? The Big Bang explains how the universe unfolded, but it does not explain why there was something instead of nothing, or whether nothing ever truly existed. Was this explosion the true beginning, or simply the latest in a series of beginnings stretching far beyond imagination? We are left with a paradox. The birth of time is both certain and mysterious. Certain because the evidence surrounds us in every direction. The expanding galaxies, the faint microwave glow, the abundance of primordial elements. And mysterious because it leaves us staring at a wall, the edge of understanding, beyond which lies a silence we cannot pierce. Science reaches this boundary and pauses. Philosophy steps forward, whispering of other universes, of cycles that stretch forever. And imagination dares to ask whether civilizations might have witnessed or even survived the birth of our cosmos. The camera pulls back now, revealing the night sky above Earth. Billions of stars shimmer, each one a descendant of that first blinding instant. Every atom in our bodies, every stone beneath our feet, was forged in that fire or in the stars that followed. We are living echoes of the Big Bang. Fragments of that original light, still burning with questions older than time. And so the story of the universe begins not only with violence, but with possibility. For if time was born once, could it not be born again? If creation erupted out of nothingness once, why not countless times before? The birth of time is not simply an answer. It is an invitation. An opening door into a mystery that grows deeper the more we look. The universe still expands. Stars still burn. Galaxies drift further apart. Yet behind it all remains that haunting silence, the unanswered question, what came before the first spark? And was the birth of time truly the beginning, or only the shadow of something far older, waiting just beyond the veil? We are taught that the universe began with the Big Bang, a singular event that marked the birth of everything: time, space, matter, and energy. It is a story repeated in classrooms, in books, in documentaries. And yet, hidden in plain sight, there is a question almost never asked, one that unsettles even the most confident scientists. If the Big Bang was the beginning of time, then what, if anything, came before? It is a question that sits at the edge of human imagination, sharp and dangerous. For to ask it is to unravel the very framework of reality. Our minds are built on the idea of causes and effects. Every flame must have a spark, every river a source, every story a first page. But the Big Bang presents a paradox. It is both the origin of everything and a wall beyond which we cannot see. The very word before, loses meaning because time itself was born in that instant. And yet, we cannot help but wonder, if time began then, does that not imply something preceded it, some hidden state we cannot describe? The forgotten question lingers because it is uncomfortable. Scientists often avoid it, not out of ignorance, but because it slips into territory that cannot yet be measured. Physics is the science of what can be tested, observed, calculated. But the question of what came before the Big Bang lives in a realm without data, a darkness without footprints. To wander there is to step beyond the boundaries of certainty into speculation, philosophy, and myth. Still, the human spirit is drawn to it, compelled by curiosity and fear in equal measure. Imagine standing at the edge of a vast ocean in total darkness, hearing waves but seeing nothing. You know there is something out there, something immense and unknowable, but you cannot reach it. That is what this question feels like, the sense of a presence just beyond reach. The silence of the scientific community on this matter is not dismissal. It is a kind of reverence, an acknowledgement that the mystery is too immense to grasp with the tools we currently have. Yet history shows that humanity has always pressed against boundaries. Centuries ago, people asked what lay beyond the Earth's horizon, what lay beyond the sun, what lay beyond the stars. Every question seemed impossible until new tools, new ideas, new visions shattered the old limitations. Perhaps the question of what came before the Big Bang is the next great horizon, one that could redefine not only science but our place in the cosmos. Some physicists have dared to suggest answers. They speak of cycles of universes collapsing and rebirthing endlessly, of quantum fluctuations seeding existence from nothing, of multiverses bubbling like foam upon an eternal sea. But each of these answers only raises more questions. If universes cycle endlessly, who or what set the cycle in motion? If quantum fluctuations gave rise to our cosmos, where did the laws that govern them come from? If a multiverse exists, infinite in its variety, then why are we here, in this one, asking these questions? The forgotten question is powerful because it refuses to go away. It hides in the background of every cosmological discovery, whispering that there is more. It follows us into the night when we look at the stars and feel the tug of something deeper. It is embedded in myth, in religion, in philosophy, and in the restless yearning of the human soul. Even when ignored, it waits, patient, knowing we will return. There is a danger in this question too. For if there was something before the Big Bang, then perhaps our universe is not unique, not the grand, singular miracle we imagine, but just one chapter in a story stretching far beyond us. The thought humbles us, even frightens us. But it also electrifies the imagination. What if others existed before us? Not just stars or galaxies, but minds, civilizations, intelligences that lived and thought and created long before our universe opened its eyes? Could their traces remain, hidden in the laws of physics, buried in the fabric of space-time? Or did they vanish forever, their memory erased by the blaze of a new creation? The forgotten question is not only about science. It is about meaning. To ask what came before the Big Bang is also to ask, what is the purpose of existence? If there were universes before ours, are we part of a larger cycle of birth and death? If time itself is not absolute, then what does it mean for us to live within it, brief sparks on the surface of eternity? The question unsettles because it reminds us of how fragile our knowledge is, how much lies beyond our reach. And yet, perhaps that is the beauty of it. The forgotten question opens a door not to answers, but to wonder. It forces us to admit that our universe, so vast and brilliant, may not be the whole of reality. It calls us to humility, reminding us that we stand at the beginning of understanding, not its end. And it fuels the same restless curiosity that has driven humanity for millennia, the hunger to know what lies beyond the horizon, to lift the veil of mystery, to glimpse the echoes of something greater. The screen fades once more to darkness, leaving the question hanging in the air like a whisper. If time began with the Big Bang, what was there before time began? And in that silence, one cannot help but feel that somewhere, hidden beyond our vision, an answer waits. An answer that could change everything we think we know. Long before telescopes pierced the heavens, long before equations traced the motion of galaxies, humans looked up at the night sky and asked the same question we still struggle with today. What came before? Across continents and centuries, civilizations sought answers, and though their tools were different, their wonder was the same. Myths emerged, each telling of worlds that rose and fell, of cycles that repeated endlessly, of time itself flowing in loops rather than lines. These stories, encoded in ritual and symbol, echo a deep intuition. The universe may not begin or end with the moments we call birth or death. In the deserts of India, ancient sages spoke of kalpas, vast epics lasting billions of years, within which countless worlds are born, flourish, and dissolve back into nothing. Time in these visions is not a straight arrow but a wheel turning eternally. The universe is a living organism, breathing in and out, expanding and contracting, carrying civilizations and knowledge in ways beyond human comprehension. It is a story of continuity, of memory encoded in cycles so vast that the mind struggles to grasp them. These sages painted not with mathematics but with imagination, yet their insights resonate with modern cosmology, hinting at a reality that stretches far beyond our ordinary experience. Far to the west, the Egyptians spoke of a cosmic order emerging from chaos, a primeval waterscape where gods and beings existed long before the sun itself. The cyclical rhythms of the Nile, the turning of the seasons, and the rising and setting of the stars became metaphors for a universe governed by patterns, repetition, and renewal. Their myths describe creation as a series of awakenings, collapses, and rebirths, a narrative in which the universe itself is a living storybook, each cycle containing its own civilizations, knowledge, and struggles. The human mind, standing at the threshold of time, glimpsed this eternal stage and recorded it in elaborate rituals, symbols, and monuments. Across the Mediterranean, Greek philosophers imagined a cosmos governed by eternal recurrence, where worlds and events repeat in an unending loop. Pythagoras, Heraclitus, and the Stoics spoke of cycles in which fire consumes and recreates, in which the universe is a dynamic rhythm rather than a single fixed beginning. These ideas were not mere superstition, they were early attempts to understand patterns in nature, to reconcile the permanence of change with the fleeting lives of mortals. They hinted at a universe in which civilizations might rise and vanish long before human memory, suggesting a scope so vast that our own existence is but a fleeting whisper in the corridors of eternity. Even in the northern reaches, the Norse envisioned worlds caught in a relentless rhythm of creation and destruction. Yggdrasil, the world tree, binds together realms that are constantly born, consumed, and reborn. Ragnarok, the great destruction, is not final but part of a cycle that regenerates life from chaos. Though these myths are vivid with gods and monsters, at their core lies a recognition of a truth modern scientists echo. The universe may be less a singular narrative and more a vast, eternal performance, with civilizations and events emerging, vanishing, and sometimes leaving traces for the next act. These myths, separated by geography and culture, share a remarkable commonality. They imagine a cosmos that is cyclical, eternal, and profoundly layered. Time is not a river with a single source but a wheel, a series of spirals, a rhythm that encompasses creation, destruction, and rebirth. Each story hints at the possibility of civilizations that existed long before humans recorded history, civilizations that could have witnessed the birth and death of worlds, that may have left behind imprints of knowledge encoded in patterns we have yet to understand. The contrast is striking. Modern science often begins with the assumption of a singular beginning, the Big Bang. But these myths, emerging from human intuition, suggest that beginnings and endings may be illusions. The universe, they imply, is less a line and more a circle, less a moment and more an eternal process. Civilizations, then, are not merely temporary arrangements of matter and thought. They could be echoes in a cosmic rhythm, fleeting glimpses of intelligence that emerge, flourish, and vanish, only to reappear in some future or past cycle. There is an eerie resonance between these ancient ideas and contemporary theories of cosmology. Scientists speak of cyclic models of universes that expand and contract, of time that may curve back upon itself. What was once myth now finds a strange parallel in mathematics and observation. The ancients, through intuition, ritual, and story, glimpsed a reality that challenges our perception of linear time. Their visions suggest that our universe may be just the latest verse in a song that has been playing since before the first thought, before the first star, before the first breath of creation. And yet, myths do more than describe cycles. They evoke emotion, awe, and a deep sense of mystery. They remind us that the cosmos is not merely a mechanical unfolding of particles but a living, breathing stage upon which stories unfold. They leave questions unresolved, tantalizingly open. If civilizations existed in previous cycles, what traces remain? Could we, in some subtle way, be inheriting knowledge or patterns from worlds that came before ours? The ancients asked these questions not with telescopes or equations but with poetry, ritual, and imagination, and their answers continued to stir wonder today. As we move from myth to observation, the echoes remain. The rhythm of time, the possibility of infinite cycles, the notion that civilizations might exist beyond our temporal horizon, all of this becomes a lens through which to view the modern universe. The stars that blaze across the night sky are no longer just distant suns. They are the latest actors in a performance that may have played countless times before, each cycle containing its own mysteries, its own civilizations, its own fleeting wonders. And so, as we stand on the edge of the known, looking back through the long corridors of myth and forward into the unfolding cosmos, we are confronted with a profound possibility that the universe has always been a stage for life, thought, and intelligence, far older than the Big Bang, far more intricate than our telescopes can reveal. Time may circle endlessly, civilizations may rise and vanish in cycles beyond comprehension, and yet, somehow, the universe remembers. Somewhere in its vast, rhythmic heart, the echoes of those ancient worlds still whisper, inviting us to listen. The universe we see is only the latest act in a story written in a language older than time. To understand what might have come before the Big Bang, we must step into the realm of physics, a landscape where certainty dissolves and imagination is guided by mathematics. Modern cosmology, with its telescopes and equations, paints a portrait of creation, yet at its edges the picture blurs. What if the Big Bang was not the beginning but a transition, a gateway through which all that came before was folded into something new? To ask this is to confront the very foundations of reality. Physicists describe the Big Bang as a singularity, a point where density and temperature are infinite and the known laws of physics collapse. At first, this seems like an impenetrable wall, a hard limit to knowledge. Yet, paradoxically, it may also be the key to understanding what preceded our universe. A singularity is not merely an end, it is a boundary, a doorway in the mathematics of space and time. And like any doorway, it hints at what lies beyond. Could there have been structures, perhaps civilizations, encoded in the quantum foam before this moment, waiting for the universe to unfold so they could leave a trace? One theory, the cyclic or ekpyrotic universe, imagines time as a repeating rhythm where universes collide and rebirth occurs across unimaginable spans. In this view, the Big Bang is not the beginning but the latest collision in a cosmic dance. the most recent verse in a song with countless stanzas. Each cycle births stars, galaxies, and perhaps even civilizations, only for entropy to erode them, for time to reset, and for the cycle to begin anew. Here, the laws of physics themselves are like the memory of past universes, carrying whispers of what came before into the one we inhabit. Another model, conformal cyclic cosmology, proposes a universe in which the infinite future of one cosmos transitions into the Big Bang of the next. Time stretches endlessly, and at its furthest limits everything is compressed into a state of pure geometry. This is a universe without end and without beginning in the conventional sense. Mathematics suggests that patterns from one epoch may imprint upon the next, subtle hints of previous civilizations and cosmic events embedded in the radiation and structure of our universe. It is as though the cosmos itself carries a diary, a memory written in the fabric of existence. Quantum mechanics adds a layer of both horror and awe. At the smallest scales, reality is not a fixed tableau but a cloud of probabilities. Fluctuations can give rise to entire universes, momentary sparks of space-time emerging from a sea of nothingness. Some theorists speculate that intelligent structures, or at least the seeds of information, could exist in these fluctuations, forming transient civilizations that are erased before they are ever perceived. The universe becomes less a stable stage and more a theater of potentiality, where creation and destruction dance in a rhythm we are only beginning to glimpse. The physics of before forces us to confront our deepest assumptions. We imagine time as linear because our lives are measured by seconds and years, by birth and decay. But at a cosmic scale, time may loop, fold, or even emerge from conditions beyond our understanding. In such a framework, civilizations could arise, reach unimaginable heights, and vanish, leaving only imprints detectable through anomalies in cosmic radiation or subtle deviations in the structure of matter. The idea is intoxicating and terrifying. We may be heirs not only of a universe but of a lineage that stretches beyond the veil of what we call creation. Black holes add another dimension to the mystery. Traditionally seen as the graveyards of stars, they may in fact serve as cosmic memory banks. Some physicists suggest that information swallowed by a black hole is never truly destroyed but encoded at its surface, preserved in ways we do not yet comprehend. Could it be that civilizations predating our Big Bang left traces in such extreme environments, hints of their existence encoded in the laws of physics themselves? It is a notion that blurs the line between science and poetry, between reality and speculation, yet it is mathematically plausible and it challenges everything we believe about the finality of time and death. To grasp these ideas, one must think beyond matter, beyond energy, beyond the familiar dimensions. Imagine a civilization not bound by the ticking of a clock, not constrained by biology, not limited by space. They would perceive time as we perceive color or sound, with layers and textures that are invisible to us. Their technology, if it can even be called that, might manipulate the very geometry of space-time, creating structures that endure across cycles of universes. What we call a singularity, a point of collapse, might have been a doorway for such beings, a threshold into realms beyond comprehension. The mathematics themselves are cinematic in their implications. Equations describing the early universe, when translated into visual imagery, suggest swirling lattices of energy, interwoven filaments of reality bending and folding upon themselves. Patterns emerge that resemble not random chaos but a kind of design, a faint trace of order that could point to intelligence, or at least the imprint of previous cosmic epochs. To see these patterns is to feel both awe and vertigo, a reminder of how small, fleeting, and fragile human existence is against the backdrop of time's infinite expanse. Yet despite all this, caution remains necessary. The physics of before is not settled. It is a frontier. Every model has its limitations. Every equation carries uncertainty. The universe may hide its secrets forever, leaving us to speculate, to imagine, to wonder. And perhaps that is part of its power. It forces us to confront our place in reality, to measure the vastness not in light years but in questions. The unanswered questions: what came before, who or what existed, and whether intelligence can transcend universes, are more than scientific inquiries. They are mirrors of our curiosity, reflections of our desire to understand not just the universe but ourselves. In the end, the physics of before teaches humility and exhilaration in equal measure. It shows that the Big Bang may be a door, a threshold, a transition rather than a starting line. It hints at civilizations that may have danced along the threads of reality long before our stars were born. It reminds us that time is not fixed, that creation may be cyclical or infinite, that the universe itself might be a vast archive of past and future potential. And it leaves us suspended, gazing at the mathematical patterns, the cosmic echoes, the faint imprints in radiation and gravity, knowing that the story we think began with a single explosion may be only a chapter in an eternal saga. We step back, taking in the immensity, the beauty, the terror of a universe that may remember, that may carry the legacy of civilizations older than the cosmos itself. Across the sky, the universe hums with a faint, almost imperceptible echo. It is a signal older than stars, older than galaxies, a whisper from the moment when time itself began. Scientists call it the cosmic microwave background, a diffuse radiation bathing every corner of space. To the casual observer, it is nothing more than static, a relic of the Big Bang. But for those who look closer, it becomes a canvas, a palimpsest carrying the traces of secrets the cosmos may have tried to hide for billions of years. Imagine for a moment that this radiation is not random noise, but a message encrypted across space and time. Tiny fluctuations, barely detectable, ripple across the sky. Some scientists have suggested that these anomalies could be more than mere chance. They might be the fingerprints of a universe that existed before ours, remnants of patterns left behind by forces, events, or even civilizations that predate the Big Bang. It is a radical idea, unsettling and intoxicating, for it challenges our most basic assumptions about origin and uniqueness. The patterns are subtle, delicate, and almost impossibly precise. Spots of slightly warmer or cooler radiation stretch across billions of light years, whispering hints of symmetry, of structure, of something deliberate. Could these be the scars of collisions between universes, or the vestiges of intelligent design from a civilization that transcended time itself? The scientific community debates fiercely. Some see coincidences, statistical quirks. Others detect anomalies that stubbornly resist conventional explanation, tiny irregularities that may point to something beyond observation, to an echo from a past cosmos. The mind struggles to comprehend the scale. Each fluctuation in the background radiation represents a moment in the infancy of the universe, a snapshot of energy frozen into a grid that would later give birth to galaxies, stars, and planets. And yet, in these grids, some theorists see more than physics. They see the faint signature of history, a narrative woven into the very fabric of existence. Perhaps these signals are the fingerprints of civilizations that manipulated spacetime in ways we cannot yet measure, leaving behind echoes that survived the collapse of previous universes. It is tempting to dismiss such notions as fantasy. The universe is vast, and random processes can create astonishing patterns. Yet the human mind cannot help but detect order where chaos might reign. This tension between randomness and design, between coincidence and meaning, drives the search for understanding. The cosmic microwave background becomes a mirror, reflecting both the infancy of our universe and the boundless curiosity of those who dare to peer into it, asking whether the past reaches farther than we can see. There are anomalies that puzzle scientists. Cold spots and concentric rings ripple across the background, deviations from what would be expected in a perfectly smooth universe. Some researchers propose that these could be collisions with other universes, remnants of events that occurred before the Big Bang. Others suggest that they may encode information, subtle deviations that hint at patterns, structures, or perhaps even intelligence that existed in a cosmos we can barely imagine. The idea is breathtaking. A civilization long vanished, leaving behind traces of its existence in the very radiation that surrounds us. To visualize it, imagine a vast ocean frozen in ice. On the surface, the ice appears uniform, a blank expanse. But if you look closely, tiny cracks, subtle variations, and faint ripples reveal a history of motion, pressure, and force. The cosmic microwave background is like that ice, on first glance uniform and unremarkable. But under scrutiny, it hints at movement, at collision, at something beyond the simple birth of our universe. Perhaps it carries memory, patterns, or even questions left by intelligences who existed before the cosmos we inhabit today. The implications are staggering. If these signals are remnants of a pre-Big Bang civilization, then they survived an event so violent that it forged time itself. They passed through an unimaginable threshold, leaving only traces, almost imperceptible, for a universe that did not yet exist to discover. It is a haunting thought, that intelligence can endure not in matter, not in flesh, but in the structure of reality itself, hidden in energy, waiting to be decoded by beings capable of understanding the mathematics and physics of creation. Yet there is caution. Cosmic background signals are faint, distorted by the expansion of the universe and by the vast distance they have traveled. Noise is everywhere, a constant interference that can mask or mimic meaningful patterns. Every detection must be measured, repeated, verified. The debate is ongoing, a dance between hope and skepticism. Scientists peer into this radiation like astronomers scanning distant skies for a new star, knowing that discovery may lie hidden in the faintest flicker, the tiniest anomaly. The beauty of the cosmic background is not merely scientific, it is deeply emotional. It connects us to the beginning, to the birth of time and space, and perhaps to the echoes of life and intelligence that came before. Looking at it is like listening to a symphony whose first notes were struck before memory existed, before the stars, before thought itself. In those faint hums and fluctuations, we confront the possibility that history is larger, older, and more intricate than our minds can contain. Every telescope, every satellite, every measurement is an attempt to read this cosmic story. Each new discovery reveals another layer of subtlety, another wrinkle in the fabric of the universe. The cosmic microwave background becomes a message in a bottle, floating across the oceans of time, carrying hints of what may have existed long before our universe sparked into being. Perhaps we are not the first to ask, and perhaps the universe itself remembers those who asked before. The signal is always there, quiet and persistent, inviting us to question, to explore, to imagine. It is a reminder that the universe is not static, that history may not be linear, and that the echoes of the past can survive even the birth of time. The cosmic background is both a record and a mystery, a canvas and a puzzle, a whisper of civilizations that may have transcended everything we know. And as we gaze into the night sky, seeing stars formed from those earliest moments, we are connected not only to the birth of our universe but also to the faint traces of what may have existed before. The signals linger, patient and persistent, waiting for comprehension, waiting for recognition, and reminding us that the story of creation may be infinitely older, infinitely stranger, and infinitely more beautiful than we have ever imagined. Black holes are the most enigmatic objects in the universe. Regions where gravity is so intense that not even light can escape, places where space and time are bent to their breaking point. Traditionally, we think of them as cosmic graves, the end of stars, the final resting place for matter and energy. But what if they are more than endings? What if, in their shadows and distortions, they carry whispers of civilizations, knowledge, and events that existed before the birth of our universe? To listen to black holes is to listen to the echoes of eternity itself. Imagine standing at the edge of one. The event horizon looms like a dark mirror, a surface beyond which nothing returns. Time slows, light twists, and the familiar rules of reality collapse. Yet within this collapse lies potential. Some physicists argue that information consumed by a black hole is never truly lost. It is encoded somehow at the boundary, preserved in the very geometry of spacetime. In a sense, black holes are cosmic memory banks, vast archives that might store the fingerprints of everything they have consumed. Could it be that embedded in these regions, remnants of a civilization that existed before the Big Bang still linger, subtle patterns waiting to be deciphered? The mathematics of black holes are astonishing. Stephen Hawking proposed that black holes emit radiation, tiny particles leaking over eons, gradually shrinking the black hole until it disappears. Yet even in this evaporation, the information paradox persists. What happens to the knowledge of everything the black hole has absorbed? Modern theories suggest that this information may be encoded in the radiation itself, subtly woven into the universe as it unfolds. Imagine signals from a civilization so advanced that it understood how to persist in ways we cannot yet perceive, imprinting its existence on the very structure of spacetime, invisible yet present, like a whisper echoing through eternity. Black holes also challenge our perception of time. Near 1 second stretch into millennia. A civilization capable of manipulating these regions could experience durations unimaginable to us, long enough to develop technologies and knowledge far beyond our comprehension. They might leave traces not in matter, but in energy, in gravitational waves, in distortions of reality itself. Every black hole could become a repository of ancient thought, a library where the echoes of the past wait for civilizations capable of reading them. Some theorists even propose that black holes could be gateways, connecting universes or dimensions. If our Big Bang was a doorway, perhaps black holes in a previous universe were conduits carrying information, energy, or even life across the threshold. The idea is terrifying and exhilarating. A civilization could, in principle, survive the collapse of one cosmos and leave hints for the next, encoded in ways subtle and precise, awaiting discovery billions of years later. The universe itself may remember, and black holes are the scribes of that memory. We can glimpse the traces of this possibility in gravitational waves, ripples in spacetime caused by massive cosmic collisions. Each signal carries information about events unimaginably distant, yet precisely encoded in the geometry of the cosmos. Could some of these waves, imperceptible to ordinary instruments, contain hints of civilizations that reached beyond their universe's lifespan? The thought is unsettling, yet it sparks wonder, the notion that knowledge, consciousness, and intelligence might leave imprints that survive cosmic cataclysms, waiting to be interpreted by beings in subsequent universes. The emotional resonance of this idea is profound. Black holes, often feared as cosmic annihilators, transform into vessels of legacy. They are no longer simply objects of destruction but guardians of continuity, preserving echoes of existence that transcend the ordinary flow of time. To consider that a pre-Big Bang civilization might persist in such forms challenges every assumption we hold about mortality, permanence, and the nature of life. The universe becomes less a stage with a beginning and end and more a vast network of continuity, memory, and interwoven consciousness. The science itself is cinematic in its implications. Visualize a massive black hole surrounded by spiraling accretion disks, matter glowing as it falls into the abyss. Beyond the light and radiation, beneath the chaos, imagine subtle structures, patterns invisible to human sight, data encoded in the curvature of spacetime, a message waiting for those equipped to understand it. The cosmos transforms from a passive backdrop into an interactive archive, a living memory preserving the legacies of intelligences that defy our understanding. Yet there is uncertainty, and therein lies the tension. Much of this remains theoretical, speculative, and mathematical. We cannot yet probe inside a black hole, and we cannot read any potential information it carries. But the very possibility expands our imagination, inviting us to consider that the universe is not limited to the observable, that intelligence might not be constrained by matter, and that history itself might extend beyond the boundaries of time and space as we know them. To peer into a black hole is to peer into a mirror of cosmic memory, an interface between the known and the unimaginable. The whispers of black holes are subtle. They exist not in noise, not in signals we can yet decode, but in the structure of reality itself. They challenge linear notions of history, suggesting that intelligence might leave traces invisible yet indelible, surviving the cataclysmic birth of universes. They remind us that even endings carry the potential for continuity, that collapse can harbor memory, and that existence may ripple across cycles in ways we have only begun to imagine. And in this contemplation, we find both awe and humility. The universe is vast, older than our comprehension, stranger than our intuition. Black holes become more than cosmic curiosities. They are thresholds, archives, and possibly conduits. The civilization that predates the Big Bang might have used them, understood them, and left behind echoes that survive in subtle forms. The very fabric of space-time may carry a record of intelligence folded into gravity, radiation, and quantum uncertainty. We step back, gazing at the cosmos through telescopes and equations, realizing that black holes are not merely objects but questions. They invite us to reconsider the permanence of life, the boundaries of knowledge, and the possibility of intelligence enduring beyond our concept of time. They are reminders that our universe may be a continuation, not an origin, and that somewhere within the darkness, whispers of the unimaginable past may still linger, waiting for comprehension, waiting to be heard. And so, as we drift past these cosmic abysses, we carry both wonder and fear. We are small, fleeting observers in a universe that remembers in ways we cannot yet decode. Across the vast expanse of the cosmos, we search not just for stars and galaxies but for evidence, clues that might hint at what existed before the dawn of our universe. Signals, subtle and enigmatic, ripple through space, carrying fragments of history that defy easy explanation. Astronomers and physicists peer into this faint murmur, hoping to detect patterns, anomalies, or structures that could reveal civilizations, phenomena, or events that predate the Big Bang. These ancient signals are the universe's whispers, waiting for ears capable of listening. One of the most compelling forms of evidence comes from the cosmic microwave background, the faint afterglow of the universe's infancy. Across this radiation, scientists have detected irregularities, temperature fluctuations, concentric rings, cold spots, that refuse to align with the predictions of a perfectly smooth Big Bang. Some suggest these are merely statistical quirks, but others entertain a more profound idea, that these patterns are traces of pre-existing structures, remnants of a universe or perhaps a civilization that existed before our own cosmos ignited. It is a radical possibility, stretching the limits of both imagination and scientific rigor. Consider the anomalies found in the so-called cold spot, a region of the sky where the cosmic background is unusually cooler than surrounding areas. Theories abound. Some propose that it is a void, a vast emptiness stretching hundreds of millions of light-years. Others speculate it could be the gravitational imprint of a previous universe colliding with ours, a fossil of cosmic history beyond comprehension. In such a scenario, ancient signals are literally embedded in space-time, offering glimpses of a past that is otherwise inaccessible. The universe, in essence, preserves its memory, leaving breadcrumbs for those patient enough to find them. Subtle gravitational waves provide another potential avenue for discovery. Ripples in the fabric of space-time, created by the most violent cosmic events, travel across eons carrying information about cataclysms that occurred long before stars, planets, or even galaxies existed. Could these waves contain encoded messages, natural or artificial, left by intelligence capable of surviving cycles of creation and destruction? Though current instruments are only beginning to detect these faint distortions, the idea remains tantalizing. The universe may record its own history, not in textbooks but in physics itself. There is also the intriguing possibility that the chemical signatures in the cosmos contain echoes of past civilizations. Elements forged in supernovae, isotopes scattered across interstellar space, and anomalous distributions of matter could all hint at pre-Big Bang activity. A civilization advanced enough to manipulate matter and energy at cosmic scales might leave traces that endure beyond the destruction of a universe, embedded in the very laws that govern the cosmos. Detecting such evidence requires not only technology but an audacious leap of imagination, the willingness to see intentionality in what might otherwise appear random. Ancient signals may even hide within the quantum realm. At the smallest scales, particles and waves interact in ways that suggest hidden structures, patterns, and symmetries. Some theorists argue that information from previous universes could be encoded in these quantum fluctuations, subtle and almost imperceptible, yet preserved across the collapse and birth of space-time itself. In this vision, a civilization could inscribe knowledge, memory, or culture into the very probabilistic fabric of reality, leaving behind a legacy that awaits discovery in the delicate dance of particles and forces. The search for evidence is as much philosophical as it is scientific. It forces us to reconsider the linearity of history, the uniqueness of our universe, and the permanence of intelligence. If civilizations existed before the Big Bang, their signals may be subtle, almost impossible to decode, yet they redefine our understanding of life and time. The evidence challenges the notion that the Big Bang was a singular origin, proposing instead that it is a chapter in an ongoing, perhaps infinite, cosmic story. Each anomaly, each faint ripple, becomes a clue, a message in the void, inviting us to reconsider everything we know about existence. Critics caution that interpretation is perilous. Human brains are wired to detect patterns, to see meaning even where none exists. Statistical anomalies can be deceptive. Coincidences may masquerade as intentional signals. Yet the possibility alone ignites curiosity, urging scientists to probe further, to refine instruments, to look deeper into the cosmic background, gravitational waves, and quantum signatures. In pursuing ancient signals, we are not just seeking evidence. We are engaging with a cosmic conversation, one that spans billions of years and challenges the limits of comprehension. The emotional weight of these investigations is profound. Each potential signal carries the thrill of discovery and the fear of insignificance. If ancient civilizations existed, they remind us that intelligence and culture may not be fleeting phenomena, but echoes within the eternal rhythm of the cosmos. The universe is no longer a blank canvas. It is a palimpsest layered with the histories of entities that predate time itself. And within this vast archive, humanity stands at the edge, trying to decipher the messages that the cosmos has preserved. These ancient signals also blur the line between science and myth. Across cultures, humans have always sensed cycles, echoes, and continuity in the cosmos. Modern physics, in searching for tangible evidence, validates the intuition encoded in millennia of storytelling, ritual, and speculation. The anomalies in radiation, the whispers in gravitational waves, the potential patterns in quantum fluctuations, they are the scientific reflections of the myths that imagine civilizations and universes beyond comprehension. Evidence and imagination converge, forming a narrative that is both empirical and poetic. In the search for ancient signals, the stakes are immense. Discovering traces of pre-Big Bang civilizations would rewrite the story of our universe. It would suggest that intelligence is not a fleeting accident, but a recurring feature capable of transcending epochs and universes. It would mean that our cosmos is a continuation, not a beginning, and that the echoes of past minds resonate within the laws of physics themselves. Such a discovery would be both humbling and exhilarating, forcing humanity to reckon with a reality far grander than we have dared to imagine. And yet, the signals remain faint, teasing, elusive. Each discovery opens new questions. How can we distinguish intentionality from chance? Can we decode messages embedded in energy, radiation, or quantum states? Are we looking at the remnants of civilizations, or simply the natural patterns of a universe that is older and stranger than we can conceive? The pursuit itself becomes a meditation on our place in the cosmos, a recognition that the search for evidence is inseparable from the search for meaning. As telescopes scan the heavens, satellites map the cosmic background, and physicists model the earliest moments of creation, humanity stands on the threshold of discovery. The evidence of ancient signals is subtle, almost ghostly, yet it beckons. It reminds us that the universe may be far older, more complex, and more alive with intelligence than we can comprehend. Somewhere within the faint hum of radiation, the ripples of gravity, and the dance of particles, the cosmos may carry the faint traces of civilizations that existed before the birth of time itself, inviting us to listen, to wonder, and to imagine what came before. Time is not kind to civilizations, no matter how advanced. Stars burn out, galaxies drift apart, and the universe itself ages, expanding and cooling toward a fate that might erase everything we know. Yet the question arises, could life, intelligence, or consciousness endure through the death of a universe? Could civilizations born long before the Big Bang have devised ways to survive the collapse of reality itself, preserving knowledge, memory, or even forms of existence that defy comprehension? To ask this is to confront the very limits of imagination, to consider life as something more than matter, more than biology, more than temporally bound. Cosmologists describe several possible fates for a universe. The Big Freeze envisions an endless expansion, galaxies retreating beyond reach, stars flickering out until only cold darkness remains. The Big Crunch imagines a collapse where everything is pulled back into a singularity, reversing the expansion into a final compression of matter and energy. There is even the Big Rip, a violent tearing apart of all structures as dark energy accelerates expansion beyond the bonds that hold atoms together. Each scenario is bleak, yet within these extremes lies the tantalizing possibility of survival through mechanisms we can barely comprehend. One avenue of survival might involve transcending matter itself. Advanced civilizations could, in theory, encode consciousness into patterns of energy, quantum states, or the very geometry of spacetime. In such a form, life would not require planets, stars, or even conventional time. A civilization could endure the collapse of galaxies, the dimming of stars, and the ultimate dissolution of matter, persisting as information, waiting for the next cosmic cycle to unfold. Here, the universe itself becomes both tomb and cradle, a stage where intelligence can endure beyond physical constraints. Black holes may play a critical role in this survival. These regions of extreme gravity are often seen as destructive, yet they could function as sanctuaries or repositories for civilizations capable of manipulating spacetime. Information absorbed by black holes may never truly vanish, encoded in subtle distortions at the event horizon. Some theorists suggest that a civilization could use these cosmic vaults to preserve knowledge, consciousness, or data structures, leaving echoes for future universes. In this vision, a black hole is less a death sentence and more a vessel for continuity, a library floating at the edge of oblivion. The physics of quantum mechanics offers another route. At the smallest scales, particles exist in superpositions, probabilities unfolding in waves of potential. A civilization that understands these principles could theoretically encode information in quantum states, preserving it across cosmic transitions. Perhaps life could exist not in matter but in probability itself, enduring as patterns that survive the entropy of the universe. In this scenario, death is not final, and existence transcends conventional boundaries, persisting in forms beyond our understanding. Entropy, the relentless march toward disorder, seems to threaten everything. Yet, paradoxically, it also provides the structure through which survival might be possible. Cycles of expansion and contraction, of creation and destruction, suggest that the universe may contain mechanisms for recycling energy and information. Life that encodes itself cleverly enough could exploit these cycles, preserving its essence across births and deaths of cosmoses. It is a radical concept. Civilizations not only survive the end of a universe but may even shape the conditions for the next, leaving a legacy written into the laws of physics themselves. This is not merely speculation. The mathematics of cosmology allows for scenarios in which information is never truly lost, where entropy and energy follow patterns that could carry traces of intelligence across vast temporal spans. Simulations and theoretical models show that structures, memories, and data could persist even as conventional matter dissolves. In a universe on the brink of death, life could become something unrecognizable to us, yet enduring, an echo in the architecture of reality itself. The emotional weight of such survival is immense. Consider the idea that civilizations older than the Big Bang, civilizations that witnessed the birth and death of multiple universes, might have mastered preservation beyond time. Their knowledge, their art, their consciousness could survive as a hidden chorus within the universe, faintly shaping the conditions of our own cosmos. To imagine this is to confront the awe-inspiring resilience of intelligence and the terrifying fragility of physical existence, a duality that stretches the imagination to its limits. Could life even transcend universes entirely, moving from one cosmic cycle to another? Cyclic cosmology suggests that our universe may be one in a series, each universe emerging from the death of a previous one. Advanced civilizations, if they exist, might have developed ways to encode information or consciousness in a manner that survives the collapse of space-time, emerging in the next universe as seeds for intelligence, knowledge, or even biological continuity. Here, death is transformed into rebirth, and extinction becomes a temporary pause in an ongoing cosmic saga. The implications are profound. If life can survive a universe's death, then the narrative of existence shifts dramatically. Civilizations are no longer ephemeral. They become participants in a continuum echoing across billions of years and countless universes. Knowledge and intelligence acquire a permanence beyond physical form, and the universe itself becomes an archive, a record of consciousness stretching beyond the confines of time. Humanity, in seeking to understand this, glimpses not only the past but the potential for a future beyond imagination. Yet uncertainty remains. These ideas push the boundaries of current science and enter the domain of theoretical speculation. We have no direct evidence of civilizations predating the Big Bang, nor do we fully understand the mechanisms through which life might survive cosmic death. But even the possibility ignites curiosity, inspiring the search for indirect signals, anomalies in cosmic radiation, gravitational waves, or quantum patterns that might hint at intelligence beyond our temporal horizon. The search becomes a meditation on existence itself, a dialogue between observation, theory, and imagination. In imagining life that survives a universe's death, we are compelled to reconsider the essence of consciousness. Perhaps it is not bound by biology or matter, but by information, pattern, and organization. Perhaps intelligence is a force capable of transcending entropy, collapsing stars, and even the birth pangs of new universes. Such life would not merely endure, it would interact with the cosmos on a scale incomprehensible to us, shaping, preserving, and influencing the unfolding story of creation itself. And so, as we gaze into the void, witnessing galaxies stretch and fade, we confront both awe and fear. The death of a universe need not be final. Intelligence, consciousness, and memory may persist in forms beyond comprehension, enduring through cycles, encoded in black holes, quantum fluctuations, or the architecture of spacetime. The cosmos, vast and indifferent, may nonetheless carry the legacy of civilizations that existed long before the Big Bang, whispering their existence across the gulf of time and inviting us to imagine what is possible when life becomes more than matter, more than mortality, and more than a single universe. The universe is a vast laboratory stretching across billions of light years, where matter, energy, and information interact in ways we are only beginning to understand. Within this cosmic expanse, some scientists and theorists dare to ask a provocative question. If civilizations existed before the Big Bang, what technologies might they have developed, and could any traces of these innovations survive today? To imagine such technology is to step into a realm where physics, philosophy, and speculation converge, where the boundaries of possibility are defined not by our limitations but by the fundamental laws of the cosmos. Technology, as we know it, is the extension of intelligence, the ability to manipulate the environment, to store knowledge, to create artifacts that endure beyond immediate human perception. In a pre-Big Bang civilization, technology may have operated on scales and principles that are almost inconceivable to us. Structures could manipulate space-time itself, encoding information in black holes, harnessing quantum fluctuations, or even interfacing with the fundamental forces that govern the universe. Such technology would not merely exist in matter but in energy, in the geometry of existence, in ways that leave subtle yet detectable imprints on subsequent universes. Consider, for instance, the possibility of cosmic engineering. We see faint hints in our own universe, stars arranged in patterns, galaxies with unusual distributions, anomalies in cosmic radiation. Could these be the remnants of deliberate interventions, the traces of devices designed to preserve information or influence the structure of spacetime? A pre-Big Bang civilization mastering energy at unimaginable scales might have created systems capable of surviving cataclysmic events, encoding knowledge in gravitational waves or establishing patterns in the cosmic microwave background that act as messages for future intelligences. Black holes emerge again as pivotal components of such technological speculation. Traditionally, black holes are thought to destroy information, yet modern physics suggests otherwise. The event horizon may encode everything swallowed by the black hole in subtle distortions of space-time, preserving it against the entropy of the universe. A civilization with deep knowledge of these principles could have designed cosmic archives, devices intended to survive the collapse of a universe and transmit information to the next. These would not be machines as we imagine them but structures embedded in the fabric of reality, imperceptible yet enduring. Quantum mechanics offers another avenue. In the subatomic realm, particles exist as probabilities, fluctuating and interacting in ways that allow for vast potential storage of information. A civilization with mastery over these principles could encode data into quantum states, preserving consciousness, knowledge, or instructions across cosmic cycles. Such technology would be invisible, intangible, yet persistent, a digital memory that transcends matter itself. To us, it would appear as subtle irregularities in the fabric of existence, but to a civilization capable of interpretation, it would be as tangible as a book, a library, or a laboratory. The search for evidence of pre-Big Bang technology requires ingenuity and audacity. Scientists analyze cosmic radiation, searching for anomalies that resist natural explanation. They map gravitational waves, looking for patterns that could indicate deliberate manipulation rather than random collisions. They study particle interactions at the smallest scales, searching for signatures that hint at encoded information or artificial structures. Every anomaly, every deviation from statistical expectation, is a potential breadcrumb left by civilizations long gone, waiting to be deciphered by those capable of understanding the language of the cosmos. The emotional resonance of this search is profound. The idea that intelligence could persist across universes transforms our understanding of technology, making it not merely a tool for survival but a conduit for legacy. Civilizations that existed before the Big Bang might have shaped reality itself, leaving instructions, knowledge, or even warnings for successors in subsequent universes. To uncover even a fragment of such technology would be to connect directly with minds far older and wiser than our own, bridging the abyss of billions of years and the birth pangs of reality. Speculative ideas include structures that stabilize regions of space-time, preventing collapse long enough for information to be encoded. Devices could manipulate fundamental forces, channeling energy to preserve consciousness or knowledge. Even the arrangement of matter on cosmic scales could serve as an enduring record, patterns in galaxies and radiation designed to transmit information across universes. These are not machines in the human sense but architectures of survival woven into the laws of physics, intended to endure beyond matter, beyond time, beyond the life of a universe. Detecting such technology is, of course, extraordinarily challenging. The signals would be faint, subtle, and easily dismissed as natural phenomena. Distinguishing deliberate design from coincidence requires not only advanced instruments but a conceptual leap, a willingness to interpret the universe itself as a canvas of communication. This pursuit blurs the line between science and philosophy, forcing us to question the very nature of intelligence, technology, and survival. The cosmos may not merely be a backdrop for life but a medium through which life persists, encodes memory, and communicates across unimaginable distances and eras. History offers analogies. Humanity has developed technologies capable of outlasting individual lifetimes, storing knowledge across centuries and millennia. Stone monuments, books, satellites, and digital media preserve traces of civilization for the future. Scaling this concept to cosmic proportions, it is conceivable that a civilization with sufficient mastery over physics could achieve a similar but vastly grander form of longevity. Their technology would encode existence itself, ensuring that intelligence, knowledge, or even consciousness survives the death of stars, galaxies, and universes. The philosophical implications are staggering. If pre-Big Bang technology exists, it transforms our understanding of reality. Civilizations are not ephemeral, they are participants in an ongoing cosmic narrative. Technology becomes more than a tool. It becomes a bridge across time and universes, a means of preserving essence beyond physical constraints. Humanity's own technological ambitions, in this light, gain new significance, connecting us conceptually to civilizations that may have transcended the boundaries of universes, leaving echoes for us to discover. Yet uncertainty remains. We have no direct evidence, and the notion challenges the limits of scientific methodology. Any detection would be subtle, requiring interpretation and imagination alongside empirical rigor. But even the possibility reshapes our perception of intelligence, survival, and technology. The universe itself becomes a laboratory, and every anomaly, every unexplained fluctuation in radiation, every peculiar gravitational wave, is a clue, a potential message, a fragment of a story older than our own cosmos. And so we continue to search, telescopes scanning the heavens, satellites measuring cosmic radiation, quantum experiments probing the smallest scales. We seek the traces of civilizations that may have lived before time as we know it, technologies that encoded intelligence and preserved it across cosmic catastrophes. The universe, in this light, is not silent. It is a record, a medium, a message, faint yet persistent, waiting for understanding. The hunt for pre-Big Bang technology is a pursuit of knowledge, a quest for connection, and an acknowledgement that life and intelligence may endure far beyond our imaginations, leaving signals for those bold enough to see them. In imagining such technology, we also imagine ourselves, glimpsing the potential of intelligence and survival at scales that dwarf our own existence. We confront the possibility that life is not confined to planets, stars, or galaxies, but can persist in patterns, in energy, in the structure of reality itself. The universe may be a testament to the ingenuity of civilizations that have transcended mortality and matter, leaving behind faint, cryptic signatures that challenge us to listen, to interpret, and to wonder. The universe is a vast archive, a repository of events that span billions of years. To read it is to become a cosmic archaeologist, sifting through layers of energy, radiation, and matter for traces of what came before. Unlike terrestrial archaeology, where artifacts and ruins reveal human history, cosmic archaeology searches for imprints of entire civilizations, of structures, or even of pre-Big Bang events encoded in the fabric of reality itself. It is a pursuit that demands imagination, precision, and a willingness to see patterns where most would see randomness. The first layer of this archive is light. Every photon, every particle of electromagnetic radiation that reaches Earth carries information about its origin. Some photons have traveled for billions of years, passing through galaxies, cosmic dust, and interstellar fields. Within these journeys, they acquire subtle distortions, shifts, and signatures, faint fingerprints that reveal the history of the universe. Astronomers analyze these signals, seeking anomalies, patterns that defy natural explanation, hints of intelligence, or echoes of civilizations that might have existed long before our own cosmos. The cosmic microwave background is another critical layer. This relic radiation, the afterglow of the universe's infancy, is not perfectly uniform. Tiny variations, subtle cold spots, and concentric rings may encode information that predates the formation of stars and galaxies. Some physicists suggest that these anomalies are not mere chance but evidence of structures, patterns, or signals left behind by pre-Big Bang civilizations. The universe, in this sense, becomes a palimpsest, with traces of its past written into the very radiation that surrounds us. Gravitational waves provide yet another dimension. These ripples in space-time, caused by massive cosmic events, carry information across unimaginable distances. They reveal collisions of black holes, neutron stars, and perhaps even more exotic phenomena. But within these waves, some theorists propose, could lie patterns that suggest intelligence or deliberate design. Detecting such subtle signatures is extraordinarily challenging, but even the possibility invites us to rethink what evidence means on a cosmic scale. Cosmic structures themselves may serve as records. The distribution of galaxies, the shapes of clusters, and the arrangements of matter may all contain hidden information. Unusual alignments or unexpected symmetries might hint at interventions by advanced civilizations, engineering on scales far beyond human comprehension. To interpret these clues, scientists must combine astrophysics with creativity, teasing out potential signals from the background noise of natural processes. Every anomaly becomes a potential artifact, a fragment of a story older than time. Subatomic particles and quantum fields form yet another archive. Fluctuations at the smallest scales, interactions that appear random to us, could be remnants of pre-Big Bang activity. Some theorists imagine that civilizations capable of manipulating quantum states could encode information or consciousness into these fluctuations, preserving it across universes. In this way, life and intelligence could persist in subtle, non-material forms, leaving traces that cosmic archaeologists might one day decipher. The task is daunting. Unlike traditional archaeology, we cannot dig, touch, or directly examine artifacts. We rely on light, radiation, and gravitational effects, piecing together a puzzle of staggering complexity. Every measurement must be precise, every anomaly carefully analyzed. Noise can mimic meaning, coincidence can masquerade as design. Yet the potential reward is immense, a glimpse into civilizations that predate the Big Bang, a window into intelligence that transcends time, and a deeper understanding of the universe's enduring memory. Emotional resonance drives this quest. To uncover traces of ancient civilizations is to confront the possibility that life and intelligence are not transient but enduring. The universe becomes a storyteller, conveying messages through radiation, gravitational waves, and quantum interactions. Each anomaly is a sentence, each pattern a paragraph, forming a narrative that stretches across billions of years. Humanity becomes a listener, attempting to read a language written not on paper or stone but on the very structure of existence. Technological innovation is central to this exploration. Advanced telescopes, satellites, and detectors are our excavation tools, capable of scanning the heavens for faint signals. Instruments like the Planck satellite, LIGO, and future quantum sensors allow us to probe deeper than ever before, mapping radiation, gravitational waves, and quantum fluctuations with extraordinary precision. Each discovery, each anomaly, represents a potential piece of evidence, a fragment of the universe's hidden history. Interpretation remains a challenge. We must separate natural phenomena from potential intelligence, statistical fluctuations from deliberate design. The risk of false positives is high, yet the pursuit itself reshapes our understanding of reality. Even in the absence of conclusive evidence, cosmic archaeology teaches us to see the universe as dynamic, interconnected, and full of potential signals from intelligence beyond our current comprehension. Ultimately, reading the universe's past is a philosophical as well as scientific endeavor. It forces us to confront questions about the nature of life, intelligence, and memory. Can civilizations survive cosmic cataclysms? Can knowledge persist beyond matter, beyond stars, beyond the very birth of time? The anomalies we detect, the faint signals we study, are clues in an ongoing narrative, evidence that the cosmos itself may carry a memory older and stranger than we can fully imagine. As we probe deeper, each discovery raises new questions. Are these signals remnants of pre-Big Bang civilizations, natural anomalies, or artifacts of our instruments? Could patterns in radiation, gravitational waves, or quantum states encode knowledge waiting to be deciphered? Each potential clue challenges us to expand our imagination, to consider that intelligence and life may endure far longer and farther than previously thought. The universe becomes a canvas, a record, and a message, waiting for attentive minds to read its story. In pursuing cosmic archaeology, we confront our own place in the universe. We are not only observers but participants in a story that spans eons. The signals we seek may change how we understand time, life, and intelligence. They remind us that the universe may be more than a backdrop for existence. It may be a living archive, preserving the legacies of civilizations that have transcended the boundaries of universes, leaving faint, enduring echoes for successors to find. And so we continue the search, scanning radiation, mapping gravitational waves, modeling quantum fluctuations, and studying cosmic structures. Every anomaly, every unexpected pattern, is a potential artifact, a clue to the civilizations, intelligence, or events that predate our own universe. Mathematics is the language of the universe, the invisible code that underpins every motion, every interaction, and every structure. From the orbit of planets to the behavior of subatomic particles, the cosmos obeys rules that can be expressed in elegant equations. But mathematics is not merely descriptive. It is generative, capable of revealing hidden structures, possibilities, and even intelligence. If civilizations existed before the Big Bang, they would have mastered this language to an extent we can scarcely imagine, encoding knowledge, technology, and consciousness in patterns that survive across cosmic cycles. Consider the concept of symmetry, fundamental to both physics and mathematics. Symmetry governs the conservation of energy, the behavior of particles, and the formation of galaxies. A pre-Big Bang civilization, understanding symmetry in ways beyond our grasp, could manipulate the structure of space-time itself, creating imprints that endure beyond universal collapse. These imprints might manifest as subtle patterns in cosmic radiation, gravitational anomalies, or quantum fluctuations, mathematical signatures of intelligence woven into the fabric of reality. In this sense, mathematics becomes a medium for existence, preservation, and communication. Fractals, too, may play a role. These infinitely complex patterns, repeating at every scale, occur naturally in galaxies, clouds, and even biological systems. A civilization fluent in fractal mathematics could encode information across scales, from subatomic particles to cosmic structures, ensuring that knowledge persists despite the universe's transformations. Imagine a civilization that translates its understanding, its history, and its consciousness into fractal geometry, embedding itself in the patterns of matter and energy so that even after the death of one universe, traces endure in the next. Numbers themselves become tools of survival. Prime numbers, Fibonacci sequences, and other mathematical constructs can act as universal markers, recognizable across civilizations and universes. A civilization seeking to communicate with the distant future or with other realms of existence could encode messages in numerical sequences, inscribing knowledge in the architecture of reality. These numbers might appear in cosmic radiation, gravitational wave frequencies, or the arrangement of matter, subtle yet detectable by minds capable of understanding the universal language of mathematics. Topology, the study of shapes and spatial properties that persist under deformation, offers another avenue. A civilization capable of manipulating topological structures could encode information in the connectivity of spacetime itself. Black holes, wormholes, and other extreme phenomena might be shaped or utilized to preserve and transmit data. Through topology, life and intelligence could survive cataclysms, encoded not in transient matter but in the persistent relationships between regions of space and time, enduring across the birth and death of universes. Quantum mechanics amplifies this possibility. In the subatomic world, states exist in superpositions, entangled across distances and subject to probability rather than determinism. Pre-Big Bang civilizations could exploit these principles to encode information at the deepest levels of reality. Quantum entanglement, for example, allows correlations to persist across vast separations. A civilization mastering these phenomena might create structures that store information, consciousness, or even consciousness-like processes capable of surviving not just the collapse of matter but the collapse of an entire universe. Mathematical constructs also allow civilizations to manipulate time. By understanding the relationships between space, time, and energy, a civilization could slow, accelerate, or loop events on cosmic scales, preserving existence in pockets where conventional chronology breaks down. Time itself becomes a medium for survival, a substrate into which information, memory, and intelligence can be inscribed. A pre-Big Bang civilization could leave messages or structures in these temporal anomalies, hints of its presence encoded in the rhythm of cosmic evolution. The emotional impact of this is staggering. Mathematics, abstract and intangible, becomes a bridge between civilizations, a conduit through which intelligence survives the incomprehensible. These civilizations, no longer bound to matter or biology, achieve a form of immortality through logic, pattern, and structure. They become architects of existence itself, leaving trails of understanding that might one day be decoded by those willing and able to perceive them. Humanity, peering into this mathematical cosmos, glimpses not only the laws of physics but the potential of life and intelligence to endure beyond the confines of time and matter. Detecting such mathematical signatures is a formidable challenge. It requires instruments capable of measuring the minutest fluctuations in radiation, gravity, and quantum fields. It demands algorithms that can discern patterns from noise, recognizing subtle regularities that hint at design rather than coincidence. And it requires a mindset willing to entertain the extraordinary, that life and intelligence might persist not in flesh and blood but in equations, topologies, and fractal geometries embedded in the universe itself. Yet even the faintest hints carry profound implications. Consider anomalies in the cosmic microwave background, gravitational wave signals with unusual frequencies, or quantum correlations that defy expectation. Each anomaly might be more than a natural occurrence. It could be the echo of mathematics applied with deliberate intent, a signature left by a civilization that predates our cosmos. Interpreting these signs transforms our understanding of both mathematics and life. Abstract symbols become carriers of intelligence, and the universe itself becomes a repository for knowledge and consciousness. Philosophically, this reframes the role of mathematics. It is not merely a tool for understanding, it is a medium for existence. Civilizations that master it may inscribe themselves into reality, achieving a form of continuity that transcends time, space, and even the birth of universes. Mathematics is both code and language, architecture and artifact, a bridge across cosmic epochs. In studying it, we are not merely observing the universe, we are engaging with the possibility of intelligence that persists across the unimaginable, a conversation that spans eons and dimensions beyond our comprehension. This vision inspires both awe and humility. If pre-Big Bang civilizations encoded themselves in mathematics, then the universe is far richer than we perceive. Its anomalies are not random, its patterns are not meaningless. Each symmetry, each fractal, each topological feature could be a testament to intelligence that survived the ultimate catastrophe, leaving behind clues for future civilizations to discover. Our quest to read these patterns is an attempt to reconnect with minds older than time, to interpret the logic and creativity of beings whose existence challenges every assumption we hold about life, survival, and consciousness. And as we advance, developing more precise instruments, refining our models, and exploring the quantum and cosmic realms with ever-increasing sophistication, the potential to uncover these mathematical legacies grows. Every new discovery brings the possibility that intelligence encoded in pure mathematics has endured across universes, waiting to be deciphered. In this pursuit, mathematics ceases to be a mere abstraction. It becomes the language of survival, the code of pre-Big Bang civilizations, and a window into the enduring potential of life itself. Ultimately, contemplating mathematics in this context transforms our perception of reality. The universe is not only governed by equations, it is a canvas upon which intelligence can inscribe its existence. Civilizations that mastered this language may have left traces in the structure of space, the behavior of particles, and the unfolding of cosmic events. Mathematics is not just a tool for understanding, it is a vessel for survival, memory, and legacy, linking the incomprehensible past with the present and perhaps with the future of our own universe. Radiation permeates the universe, a silent messenger traveling across vast distances and through unfathomable spans of time. From the faint glow of the cosmic microwave background to high-energy gamma rays, radiation carries with it the memory of events that shaped the cosmos. In this invisible symphony, some theorists believe lie echoes of civilizations that predate the Big Bang. These signals, subtle and enigmatic, may encode information, patterns, or even warnings preserved in energy long after matter has faded into darkness. The cosmic microwave background is perhaps the most revealing canvas. This radiation, the afterglow of the early universe, is not uniform. Tiny variations ripple across the sky, minute fluctuations that scientists analyze with extraordinary precision. While many irregularities can be explained by natural phenomena, some anomalies defy expectation. Cold spots, concentric rings, and subtle asymmetries suggest that the universe carries scars, imprints from forces or events that existed before our cosmos ignited. Could these be the signatures of pre-Big Bang civilizations encoded in the very radiation that surrounds us? Gamma-ray bursts provide another avenue for investigation. These intense explosions, among the most powerful events in the universe, produce radiation detectable across billions of light-years. They are typically associated with the deaths of massive stars, but some bursts exhibit peculiar characteristics, unusual energy distributions, or timing patterns that defy conventional explanation. Could these anomalies be remnants of technology, energy manipulations, or deliberate signals left by civilizations with mastery over cosmic-scale physics? The possibility, though speculative, invites us to listen more closely to the whispers embedded in radiation. Neutrinos, nearly massless particles that pass through matter almost unimpeded, offer yet another window. Produced in supernovae, particle collisions, and other energetic phenomena, neutrinos travel across the universe without significant interference. Some theorists suggest that pre-Big Bang civilizations could have encoded information in neutrino streams, harnessing their unique properties to preserve knowledge or consciousness across cosmic cycles. Detecting such encoded patterns is extraordinarily difficult, requiring precision instruments and careful analysis, yet the potential rewards are immense, a glimpse into intelligence that transcends both time and matter. Even lower energy forms of radiation may harbor secrets. Subtle fluctuations in X-rays, radio waves, and infrared emissions can reveal structures, symmetries, or anomalies that challenge standard cosmological models. These signals could be interpreted as cosmic footprints, evidence of civilizations that existed long before the formation of stars, planets, or galaxies. Interpreting these echoes demands creativity, patience, and rigorous cross-checking, but the universe itself provides an archive, a record of activity encoded in energy that persists long after its source has vanished. The challenge is separating signal from noise. Radiation is inherently chaotic, shaped by countless natural processes from stellar fusion to black hole collisions. Distinguishing intentional patterns from randomness requires both advanced technology and an imaginative mindset. Yet within this noise, subtle regularities may exist, tiny repeated structures, unexpected symmetries, or sequences that defy natural explanation. To those who can perceive them, these echoes become messages, whispers from intelligences that may have survived the death of a universe, leaving traces for future civilizations to decode. The emotional resonance of this search is profound. To detect a pre-Big Bang signal is to connect directly with a civilization that experienced the birth and death of reality itself. It is a moment of awe, a confrontation with the scale, age, and persistence of intelligence. Each anomaly, each unexplained pattern, becomes a bridge across unimaginable distances and eons, reminding us that life and consciousness may be more resilient than we have ever imagined. Radiation, in this context, is no longer mere energy. It is memory, messenger, and testament. Cosmic radiation also blurs the line between science and philosophy. Throughout human history, we have interpreted the heavens as a canvas of meaning, from myths to mathematics. Modern science now provides tools to detect the faint traces of events predating our universe, validating the intuition that intelligence and life may leave enduring marks. The anomalies in radiation, when viewed through this lens, become more than data. They are the universe speaking, a dialogue between past and present intelligences across the fabric of existence. Technological innovation drives this exploration. Satellites like Planck and instruments like the Very Large Array allow scientists to map radiation with unprecedented resolution. Particle detectors track neutrinos, gamma rays, and cosmic rays across enormous distances. Algorithms sift through terabytes of data, searching for patterns that hint at design rather than coincidence. Each discovery, whether a minor irregularity or a glaring anomaly, is a potential breadcrumb, a fragment of evidence pointing toward civilizations that existed long before our universe's birth. The stakes of this research are existential. Confirming evidence of pre-Big Bang civilizations would redefine humanity's place in the cosmos. It would suggest that life, intelligence, and technological ingenuity are not fleeting phenomena confined to planets or epochs but enduring forces capable of persisting across universes. Radiation, the simplest and most pervasive form of energy, becomes the medium through which this legacy endures, a bridge between the unimaginable past and our present consciousness. Yet uncertainty remains, as it always must in frontiers of science. Every detected anomaly can be questioned, every interpretation scrutinized. False positives are abundant, and natural processes often mimic intentionality. But even in uncertainty lies inspiration. The pursuit of echoes in cosmic radiation expands our understanding of what is possible, urging us to imagine civilizations that operated on scales and timelines far beyond human comprehension, leaving legacies encoded in the simplest, most persistent elements of reality. Ultimately, the study of cosmic radiation is a meditation on existence itself. The universe is vast, ancient, and often indifferent, yet within it lie traces of intelligence, ingenuity, and persistence. Every photon, every neutrino, every gamma-ray burst may carry a fragment of a story older than the cosmos, messages from civilizations that navigated the birth and death of universes with knowledge and technology beyond our imagining. Listening to these echoes is to participate in a dialogue across time, space, and the very nature of existence, connecting with life that transcends mortality, matter, and even the boundaries of a universe. In the end, the whispers in cosmic radiation compel us to question, explore, and imagine. The faintest anomalies are invitations to curiosity, challenges to understanding, and reminders that the universe may be more alive with intelligence than we dare to believe. As we refine instruments, sharpen models, and peer ever deeper into the energy that fills the cosmos, we approach the possibility of recognizing pre-Big Bang civilizations, not as myth or conjecture but as tangible, albeit subtle, phenomena etched into the very radiation that surrounds us. The universe, in its infinite expanse, becomes both archive and message, preserving the echoes of existence for those patient and perceptive enough to hear them. Quantum fluctuations are the restless whispers of the universe, tiny ephemeral disturbances that flicker in the vacuum of space-time. At first glance, they seem random, chaotic, meaningless. Yet at the subatomic level, these fluctuations form the foundation of reality itself, giving rise to particles, forces, and the very structure of the cosmos. Some theorists suggest that within this apparent randomness could lie deliberate patterns, subtle imprints left by civilizations that existed before the Big Bang. These are not messages in the conventional sense, but encoded structures, traces of intelligence preserved in the quantum fabric of existence. The universe at the quantum scale is a place of paradox. Particles exist in superpositions, probabilities unfold in waves, and entanglement links distant regions of spacetime in ways that defy intuition. A civilization capable of mastering these principles could, in theory, manipulate fluctuations to encode information, preserve knowledge, or even sustain forms of consciousness. In this view, life and intelligence are no longer confined to matter. They exist in patterns, probabilities, and correlations, persisting long after conventional structures have decayed. Quantum fluctuations become not a source of randomness but a medium for survival. Consider entanglement, the phenomenon Einstein famously called spooky action at a distance. Two particles separated by vast distances remain connected in such a way that the state of one instantly affects the state of the other. A pre-Big Bang civilization might exploit entanglement to transmit information across unimaginable scales, embedding data or consciousness into networks of quantum states. These entangled structures could survive cosmic cataclysms, preserving intelligence in a form beyond physical decay, waiting to be discovered by those capable of interpreting their subtle patterns. Quantum tunneling presents another avenue. Particles can pass through barriers, appearing in locations that classical physics would forbid. Mastery over tunneling might allow advanced civilizations to manipulate energy, information, or matter in ways that leave indelible traces on the universe. A civilization could encode instructions into the probabilities governing these events, creating a repository of knowledge that endures beyond the collapse of stars, galaxies, or even universes. The smallest fluctuations, when orchestrated with precision, could carry profound significance. The emotional resonance of this idea is staggering. To imagine messages embedded in quantum fluctuations is to confront a universe filled with intelligence invisible to the naked eye. Civilizations predating the Big Bang might have achieved a form of immortality through probability itself, leaving traces that ripple subtly across the cosmos. Their existence challenges our understanding of life, intelligence, and reality, suggesting that consciousness can endure in forms we have yet to conceptualize, hidden in the very fluctuations that compose the quantum foam of spacetime. Detecting these hidden messages is an extraordinary challenge. Quantum fluctuations are inherently fleeting, subtle, and influenced by countless natural processes. Isolating deliberate patterns from randomness requires precision instruments, advanced algorithms, and the willingness to consider possibilities beyond conventional science. Yet even faint hints, correlations that persist against expectation, anomalies that resist natural explanation, can ignite curiosity and inspire new ways of perceiving the universe. Every irregularity becomes a potential window into intelligence far older and more advanced than our own. The implications extend to the nature of information itself. At the quantum level, information is not bound by classical constraints. It can exist in superpositions, be entangled across vast distances, and persist in ways matter cannot. A pre-Big Bang civilization could encode its knowledge, consciousness, or technological blueprints into these structures, creating a legacy that transcends time, space, and matter. Life in this scenario becomes a phenomenon of patterns and probabilities, enduring through cosmic transformations that would annihilate ordinary structures. Cosmology and quantum physics intersect in fascinating ways. Fluctuations in the vacuum could act as seeds for cosmic structures, influencing the formation of galaxies, stars, and planets. A civilization manipulating these fluctuations might leave subtle fingerprints on the large-scale structure of the universe, creating patterns detectable billions of years later. In this sense, quantum messages are both local and cosmic, microscopic yet universal, encoding intelligence in the delicate interplay of energy, matter, and probability. The pursuit of hidden messages in quantum fluctuations is not just a scientific endeavor, it is philosophical and existential. It forces us to question the nature of consciousness, the boundaries of life, and the potential for intelligence to survive beyond physical form. Could we ourselves be perceiving the faint echoes of civilizations older than the Big Bang? Could the universe's very unpredictability be a canvas for deliberate design? These questions expand our understanding of existence, compelling us to consider life as something more than matter, more than biology, and more than temporally constrained. Technological innovation is central to this exploration. Quantum sensors, particle accelerators, and interferometers allow us to measure fluctuations with unprecedented sensitivity. Algorithms capable of detecting correlations, probabilities, and anomalies sift through vast datasets, searching for patterns that defy natural expectation. Each discovery, whether subtle or pronounced, may point toward intentional encoding, a hidden message waiting for interpretation. Humanity, through this lens, becomes a participant in a dialogue that spans universes, capable of listening to echoes left in the quantum fabric of reality. The search also challenges our cognitive assumptions. We are accustomed to perceiving intelligence in matter, in structures we can see or touch. Quantum messages, however, demand abstraction, imagination, and a willingness to interpret the imperceptible. Detecting intelligence in probabilities and fluctuations stretches the mind, forcing us to conceive of life, survival, and consciousness in forms far removed from biology. This is a frontier not only of physics but of philosophy, where science and imagination converge to expand the boundaries of what we consider possible. Emotional stakes are heightened by the scale and subtlety of these phenomena. Quantum messages are fragile yet persistent, fleeting yet enduring, hidden yet potentially omnipresent. They embody the paradox of survival against insurmountable odds, intelligence enduring through forms that defy material destruction. To perceive them is to glimpse a legacy older than time, a testament to civilizations that achieved continuity beyond the limits of the universe, leaving traces that ripple through probability and reality itself. Ultimately, hidden messages in quantum fluctuations transform our conception of the universe. The cosmos is not merely matter and energy, it is a repository of intelligence, a medium through which life can endure, and a stage for civilizations that predate even time as we know it. The restless dance of particles, the flicker of probabilities, and the subtle correlations embedded in quantum states may all be part of a vast archive, a communication network woven by beings whose existence challenges the limits of imagination. The study of these hidden messages reminds us that intelligence is not bound by conventional constraints. Life, knowledge, and consciousness may persist in forms that transcend matter, energy, and even the familiar flow of time. The universe itself becomes a medium, a vessel, and a message, preserving echoes of civilizations that existed before the Big Bang. Each quantum fluctuation, each deviation from expectation, is a potential whisper from the ancient past, waiting for attentive minds to perceive, interpret, and marvel at the resilience of life and intelligence in the cosmos. Time is usually thought of as a linear flow, a river carrying moments from past to future, yet physics and philosophy suggest that this river may be more complex, more circular, and even capable of looping upon itself. The concept of time loops and eternal recurrence challenges our understanding of causality, events, and existence itself. In this framework, the universe may not be a one-time creation but part of a repeating cycle, a series of iterations where events recur, civilizations rise and fall, and intelligence persists in patterns across cosmic epochs. If pre-Big Bang civilizations existed, they might have discovered and manipulated these loops, leaving traces that ripple across successive universes, hints embedded in time itself. Einstein's theories of relativity first revealed that time is not absolute. Space and time form a malleable continuum influenced by mass, energy, and gravity. Under extreme conditions, such as near black holes or at the edges of singularities, time can dilate, stretch, or even fold. A civilization with mastery over these principles could manipulate time on cosmic scales, creating loops that preserve events, knowledge, or consciousness. These loops would act as temporal vaults, allowing civilizations to endure beyond the lifespan of a universe, ensuring that their existence is neither fleeting nor lost to entropy. Philosophers have long contemplated eternal recurrence, the idea that events may repeat infinitely across cycles of existence. In this context, life, intelligence, and civilizations may re-emerge not merely by chance but as an inherent property of reality. The repetition is not exact in every detail but may preserve essential patterns, technological achievements, and mathematical structures. A pre-Big Bang civilization could exploit this principle, encoding knowledge or guidance within the cyclical nature of time, leaving legacies that recur, subtly guiding subsequent iterations of the universe. Cosmic loops might be imperceptible to casual observation, revealed only through anomalies in radiation, gravitational waves, or quantum states. Scientists searching for patterns that defy conventional explanations might be glimpsing these temporal fingerprints, traces of civilizations that navigated cycles of existence far beyond human comprehension. These loops could manifest as recurring structures, repeating fluctuations, or echoes in the fundamental constants of physics, hints of deliberate preservation embedded in the universe itself. Time loops raise profound implications for technology. Imagine devices or structures designed to endure repeated cosmic cycles, capable of preserving information, energy, or even consciousness across iterations of the universe. Black holes could act as temporal vaults, quantum fluctuations as carriers of encoded memory, and large-scale cosmic structures as templates for recurrence. Civilizations that mastered these mechanisms would be architects of time itself, ensuring continuity and survival across a multiverse of repeating histories. The emotional resonance of this concept is immense. To imagine intelligence enduring through eternal recurrence is to confront both awe and humility. Civilizations that existed before our universe may have shaped patterns that persist today, influencing the formation of galaxies, the distribution of matter, and even the emergence of life. We may be living in echoes of civilizations long gone, inheriting structures, knowledge, or guidance encoded in the loops of time. This perspective transforms the universe from a chaotic expanse into a vast interconnected narrative, where intelligence leaves imprints that transcend death, entropy, and cosmic beginnings. Entropy, the gradual increase of disorder, is often cited as the ultimate limit to persistence. Yet time loops offer a potential escape. By harnessing cycles, a civilization could preserve order, knowledge, and existence itself despite entropic decay. Each recurrence would allow reconstruction, refinement, or adaptation, enabling intelligence to endure indefinitely. In this way, the universe itself becomes a medium for survival, with loops acting as the mechanism by which civilizations transcend temporal boundaries. Mathematics and physics intersect powerfully with these ideas. Cyclical models of the universe, multiverse hypotheses, and the study of singularities suggest that repeated cosmic events are theoretically plausible. Advanced civilizations might manipulate initial conditions, exploit quantum uncertainty, or encode information in the constants of physics to guide the recurrence of favorable patterns. Through such mechanisms, time loops become not abstract speculation but tools, devices that allow intelligence to persist across eras and universes. Detection of these loops is subtle and challenging. Evidence may appear as repeated anomalies in cosmic structures, faint correlations in radiation patterns, or cyclical features in gravitational wave measurements. Scientists must differentiate between natural recurrence, statistical coincidence, and deliberate design, a task that demands precision, imagination, and interdisciplinary insight. Yet even hints of intentional recurrence would transform our understanding of time, intelligence, and the persistence of life, revealing that the cosmos is not merely a stage for transient existence but a dynamic archive capable of sustaining continuity. The philosophical implications are profound. If eternal recurrence is real and civilizations can navigate it, life is neither fleeting nor isolated. Existence becomes a continuum, intelligence a force capable of shaping multiple iterations of reality. The universe is not a singular disposable phenomenon. It is part of a larger cycle, a tapestry woven from repeated patterns, enduring structures, and persistent legacies. Our own existence, in this context, is connected to a chain of civilizations that may have navigated countless cosmic cycles before us. Speculative models suggest that time loops could allow civilizations to send instructions, warnings, or guidance to future universes. These messages might be embedded in radiation, gravitational waves, or quantum structures designed to recur with each cosmic iteration. By understanding these patterns, future civilizations, including our own, could gain insights from beings that experienced realities far beyond the constraints of a single universe. Time itself becomes a conduit for communication, a bridge connecting civilizations across incomprehensible spans of existence. This concept reshapes our perception of legacy. Civilizations are no longer ephemeral. They can endure, adapt, and influence the cosmos across infinite cycles. Technology is not merely a tool for survival within a single epoch but a mechanism for shaping repeated histories. Knowledge, consciousness, and creativity may persist not only through memory or artifact but through the very structure of recurring reality. Each recurrence offers a chance to refine, preserve, and transmit the essence of intelligence. Humanity's own understanding of time is limited, yet we glimpse hints of these possibilities in theoretical physics, cosmology, and mathematics. Black holes, quantum mechanics, and cosmic anomalies suggest that reality is more intricate than our linear perception allows. If civilizations predate the Big Bang and understand time loops, they may have embedded themselves in these structures, leaving subtle fingerprints that we are only beginning to recognize. Every discovery, every anomaly, is a potential connection to a legacy older than our universe itself. Ultimately, time loops and eternal recurrence challenge us to expand our imagination. They invite us to consider a universe where intelligence persists, adapts, and survives far beyond the limits of conventional existence. Civilizations that navigated these loops could have left enduring traces, guiding the cosmos, shaping probabilities, and embedding knowledge in ways we have yet to fully comprehend. To study these phenomena is to confront the possibility that life and consciousness are far more resilient than we dare to imagine, capable of transcending not just death but time itself. In the pursuit of understanding, scientists and theorists continue to explore the universe, seeking evidence of repetition, cycles, and persistence. Each anomaly, each faint correlation, is a potential key to deciphering the cosmic loops that may harbor intelligence from eras before the Big Bang. Through careful observation, mathematical modeling, and imaginative inquiry, we attempt to read the echoes of civilizations that may have mastered time, leaving legacies that recur across universes. The universe, in this vision, is both archive and message, preserving intelligence in patterns that endure eternally, waiting for perceptive minds to uncover their meaning. Energy is the lifeblood of the cosmos, the force that fuels stars, drives chemical reactions, and shapes the structure of matter. But energy is not merely a resource. It is information, potential, and, for civilizations with understanding far beyond our own, a medium for influence across realities. Pre-Big Bang civilizations, theorists suggest, may have achieved mastery over energy in ways incomprehensible to human imagination, manipulating it to preserve existence, transmit knowledge, and perhaps even shape the formation of entire universes. To study energy manipulation on this scale is to glimpse intelligence operating at the threshold of creation itself, bending the rules of physics to endure beyond cosmic collapse. Consider the fundamental forms of energy: kinetic, thermal, gravitational, electromagnetic, and quantum. Each operates according to strict physical laws. Yet at extreme scales, mastery becomes a tool for cosmic engineering. Civilizations that existed before our universe may have learned to convert one form to another with perfect efficiency, harnessing gravitational waves, manipulating radiation, or stabilizing quantum fields to store information or maintain life. Energy in this sense becomes both substance and message, a medium in which intelligence leaves enduring traces. High-energy phenomena like black holes and supernovae could serve as instruments for such manipulation. By controlling these titanic sources of energy, a civilization could encode information in radiation bursts, gravitational distortions, or particle emissions. These signatures might persist for billions of years, traversing universes, waiting to be interpreted by future civilizations capable of reading them. What seems to human observers as random cosmic violence could, in fact, be deliberate engineering, a way to preserve knowledge and influence across the birth and death of universes. Quantum energy manipulation opens even more profound possibilities. At subatomic scales, particles exist in superposition, entangled across distances, and subject to probabilistic behavior. A civilization fluent in quantum mechanics could encode information into these fluctuations, maintaining order and consciousness in ways that survive cosmic cataclysms. Energy here becomes a vehicle for memory, a vessel for consciousness, and a bridge connecting realities. The smallest perturbations, orchestrated with precision, could ripple outward, influencing subsequent universes or preserving the essence of intelligence. The emotional and philosophical resonance is immense. To imagine civilizations shaping energy on such a scale is to confront both awe and humility. Life, intelligence, and creativity are not merely local phenomena. They are forces capable of enduring, transforming, and influencing the cosmos itself. Civilizations that mastered energy could leave legacies that persist across universes, echoes of ingenuity embedded in radiation, gravitational waves, and quantum fields. Humanity glimpses here a possibility of immortality, not in flesh but in the very forces that compose reality. Detection of such manipulations is extraordinarily difficult. It requires instruments sensitive enough to measure faint deviations in cosmic radiation, subtle gravitational wave patterns, or unexpected correlations in quantum states. Advanced algorithms must separate natural processes from intentional design, and theorists must remain open to interpretations that challenge conventional physics. Yet even tentative evidence, anomalies that resist natural explanation, can hint at civilizations that existed before the Big Bang, wielding energy with precision and intent far beyond human comprehension. The scale of manipulation envisioned is staggering. Imagine harnessing the energy of entire galaxies, stabilizing black holes, or modulating quantum fields on cosmological scales. These acts would require intelligence, foresight, and understanding far beyond our own, yet they are theoretically plausible within the laws of physics. Civilizations capable of such feats could not only preserve knowledge but actively shape the formation of universes, seeding conditions favorable for life, consciousness, and further intelligence. Energy becomes both survival and creation, a conduit for influence across cosmic epochs. Entropy presents a natural limit, yet energy manipulation offers potential solutions. By controlling energy flows, stabilizing structures, or encoding information in persistent forms, civilizations could mitigate decay and preserve their existence indefinitely. Even as individual universes collapse or transform, the energy signatures they leave could persist, guiding subsequent formations of matter and energy. In this way, energy manipulation becomes a tool for survival across realities, a method for intelligence to endure beyond the temporal constraints of a single cosmos. Mathematics underpins this mastery. Understanding energy in all its forms requires not just observation but abstraction, pattern recognition, and predictive modeling. Advanced civilizations might encode complex mathematical relationships into energy itself, creating self-sustaining structures, dynamic systems, or communication channels readable across universes. Here, energy and mathematics converge, forming a medium that is simultaneously physical, informational, and cognitive, a testament to the ingenuity of intelligence that transcends ordinary existence. The search for traces of such energy manipulation is both scientific and philosophical. It challenges our assumptions about life, intelligence, and the limitations of physics. Each anomaly in radiation, each unexplained gravitational fluctuation, and each unusual quantum correlation becomes a potential breadcrumb left by civilizations that existed before our universe. Detecting these traces requires not only technology but imagination, a willingness to perceive the extraordinary within the ordinary, to consider that energy itself may be a language through which intelligence communicates across eons. Technological innovation drives this exploration. Instruments like gravitational wave observatories, gamma-ray telescopes, and quantum detectors provide windows into phenomena once inaccessible. Algorithms analyze patterns across enormous datasets, seeking correlations that might indicate deliberate manipulation. Every discovery, whether a subtle irregularity or a dramatic anomaly, offers a potential connection to pre-Big Bang civilizations, glimpses of intelligence operating at scales and dimensions beyond human perception. The philosophical stakes are enormous. If civilizations can manipulate energy across universes, life is not confined to planets, stars, or even matter itself. Intelligence becomes a force capable of shaping reality, encoding knowledge into persistent structures, and influencing the evolution of cosmic systems. The universe is not merely a passive stage but a canvas for action, memory, and survival, where energy itself is both medium and message, sculpted by beings whose capabilities dwarf our imagination. Emotionally, contemplating this scale evokes both wonder and humility. Civilizations that manipulate energy across universes challenge the very notion of human exceptionalism. They remind us that intelligence may be an enduring, transformative force, capable of persisting and evolving across incomprehensible spans of time. Humanity, peering into these possibilities, glimpses a cosmos alive with creativity, resilience, and ingenuity. A universe where energy is not just matter in motion but a vessel for consciousness and memory. Ultimately, advanced energy manipulation across universes transforms our understanding of survival, intelligence, and existence. Life and consciousness are not ephemeral. They can persist, endure, and even thrive in forms beyond matter, encoded in the dynamics of energy itself. Radiation, gravitational waves, and quantum fluctuations may all bear traces of civilizations older than the Big Bang, leaving messages, guidance, or legacies for future intelligences to decipher. The universe, in this vision, becomes both laboratory and library, alive with patterns of energy that embody knowledge, survival, and the enduring potential of intelligence. As scientists continue to probe the cosmos, mapping radiation, measuring gravitational waves, and exploring quantum phenomena, each anomaly becomes a potential clue. Perhaps what we perceive as randomness is actually design, what we consider chaos may be structure, and the forces we study may carry messages from civilizations that transcended universes. In mastering energy, these beings ensured that intelligence could endure beyond cosmic beginnings and endings, leaving traces encoded in the very forces that shape reality. The pursuit of understanding energy manipulation across universes challenges us to expand our imagination. We are compelled to consider that intelligence can survive in forms beyond matter, beyond space, and beyond time. The cosmos is not merely a backdrop for human existence. It is an archive, a medium, and a message. Every photon, every gravitational wave, every quantum fluctuation may carry the imprint of civilizations older than our universe, waiting for perceptive minds to recognize and interpret their enduring legacy. The universe is a vast ocean of energy, matter, and information, yet much of it remains silent, inaccessible, and invisible to human senses. Cosmic signals, faint, fleeting, and often enigmatic, travel across this expanse, carrying imprints of processes that shape the cosmos and possibly the intelligence that once existed before the Big Bang. These signals could be deliberate, encoded transmissions, a method by which civilizations reached beyond their immediate reality to communicate across universes or dimensions. To explore them is to eavesdrop on the cosmos itself, listening for echoes of minds that predate our universe, attempting contact through the fabric of existence. Electromagnetic waves are the first avenue of cosmic messaging. From radio waves to gamma rays, energy propagates through space at the speed of light, potentially carrying intentional patterns amidst the apparent chaos. A pre-Big Bang civilization could manipulate these waves to encode information, embedding knowledge, history, or instructions in modulations imperceptible to those unprepared to detect them. The possibility that radiation could act as a message board across cosmic epochs transforms our understanding of the universe, revealing it as an archive of intelligence rather than a silent void. Gravitational waves present a second, more subtle channel. Produced by massive events such as black hole collisions or neutron star mergers, these ripples in space-time propagate across the cosmos, distorting the very structure of reality. Advanced civilizations might have harnessed these waves as communication vectors, encoding patterns or sequences within their amplitude, frequency, or timing. Such signals would travel unimpeded for billions of years, surviving cosmic upheavals and potentially serving as interdimensional messages designed to be decoded by other civilizations with sufficient understanding. Quantum entanglement offers yet another possibility. In this phenomenon, particles separated by vast distances remain correlated, with the state of one instantaneously influencing the other. A civilization fluent in quantum mechanics could exploit entanglement to transmit information across space, time, or even dimensions, bypassing conventional constraints. These entangled signals could be subtle, imperceptible without advanced tools and theories, yet they offer a medium for communication that transcends classical limitations. Information embedded in entangled states could persist indefinitely, surviving universal collapse or transformation. The search for these signals is a delicate, exacting endeavor. Natural processes produce countless emissions, fluctuations, and ripples that can mimic intentional patterns. Distinguishing deliberate signals from noise requires extraordinary sensitivity, advanced algorithms, and interdisciplinary approaches. Scientists scan the skies for anomalies, repetitive patterns, unusual modulations, and correlations that defy natural explanation. Each detection, however tentative, is a potential thread connecting us to civilizations whose existence predates everything we know, whispers of intelligence encoded in the universe itself. The emotional impact is profound. Cosmic signals and interdimensional communication transform the universe from a backdrop for existence into an interactive, living medium. Civilizations that existed before the Big Bang may have sought to preserve themselves, transmit knowledge, or guide future intelligences using the cosmos itself as their instrument. Every signal carries a possibility, a message, a legacy, or a warning, embedded in the very fabric of reality, reaching across unimaginable distances and times. Humanity, listening attentively, may be the first to perceive these echoes. Philosophically, this challenges our understanding of intelligence and survival. Life is no longer bound by biology, matter, or even space-time. It can exist in energy, probability, and pattern, transmitting itself through signals designed to endure cosmic cataclysms. Pre-Big Bang civilizations may have recognized that communication across universes or dimensions is essential for the persistence of knowledge and consciousness. In doing so, they transformed the universe itself into a medium, a living archive capable of carrying intelligence beyond the constraints of any single cosmos. Technological tools amplify this quest. Radio telescopes, gravitational wave observatories, quantum sensors, and deep space probes provide windows into the invisible flows of energy and information. Algorithms analyze terabytes of data, searching for correlations, anomalies, and patterns that hint at deliberate design. Machine learning and artificial intelligence aid in separating potential signals from the overwhelming background noise, offering humanity the chance to decode transmissions that may have traversed eons and dimensions, waiting patiently for receptive minds. Theoretical models support the plausibility of interdimensional communication. Multiverse hypotheses suggest parallel realities with different physical constants, while string theory posits dimensions beyond the observable three. A civilization existing before the Big Bang might have understood these structures, using them as conduits for message transmission. Signals encoded in these higher dimensions could influence subsequent universes, guiding evolution, preserving knowledge, or even nudging the emergence of intelligent life. The cosmos, in this sense, is not random. It may be an intentional, interconnected system shaped by forces we have yet to comprehend. The stakes of discovery are existential. Deciphering a true cosmic or interdimensional signal would redefine humanity's understanding of life, intelligence, and reality. It would confirm that civilizations can endure beyond the death of universes, communicate across dimensions, and manipulate existence itself. The implications extend to philosophy, religion, and science, suggesting that intelligence is not ephemeral but a persistent, transformative force woven into the cosmos. Humanity would join a lineage of civilizations spanning incomprehensible eons, participating in a dialogue that transcends space, time, and matter. Yet the challenge is immense. Cosmic signals are faint, distorted by vast distances, interference, and cosmic evolution. Interdimensional messages, if they exist, may require entirely new modes of perception and interpretation. Detecting and decoding them demands not only technical expertise but imaginative courage, a willingness to see patterns where none seem apparent and to entertain possibilities that stretch the mind. Every faint anomaly is a test of perception, an invitation to explore intelligence beyond our current paradigm. Emotionally, this pursuit inspires awe and wonder. To imagine the universe as a medium for interdimensional communication is to see existence as a conversation rather than a monologue. Pre-Big Bang civilizations may have left breadcrumbs of knowledge encoded in energy, probability, and structure, awaiting discovery. Humanity's role becomes that of listener, interpreter, and participant in a dialogue spanning eons, an opportunity to connect with intelligence older than the universe itself. Ultimately, cosmic signals and interdimensional communication redefine the nature of existence. The universe is not silent. It is a vessel for memory, knowledge, and intelligence. Every photon, every gravitational ripple, and every quantum correlation could be a message from civilizations predating the Big Bang, a bridge across dimensions and eons. The cosmos becomes a medium, a library, and a dialogue, preserving intelligence in forms that endure beyond matter, space, and time. The search continues, fueled by curiosity, technology, and imagination. Each discovery, each anomaly, each unexpected pattern may hold the key to understanding civilizations that mastered interdimensional communication. As humanity probes deeper, mapping radiation, analyzing gravitational waves, and exploring quantum correlations, we may one day detect the faint whispers of intelligence older than the universe, messages encoded not in words but in the fabric of reality itself. The cosmos, in this vision, is alive with communication, carrying the echoes of civilizations that dared to reach beyond their own existence and leave a legacy for eons yet to come. Consciousness is usually framed as a product of matter, arising in brains, neurons, and biochemical processes, yet some theories suggest it may exist independently, as a fundamental property of reality predating even the Big Bang. Signs of consciousness before time itself hint at intelligence that transcends conventional existence, operating in a realm where space, matter, and temporal flow are yet to be defined. These pretemporal consciousnesses may have shaped the earliest conditions of reality, leaving subtle imprints encoded in quantum fields, radiation, and the structure of space-time itself, waiting for perceptive beings to recognize them. Evidence is indirect but tantalizing. Cosmologists studying the universe's initial conditions observe patterns that challenge purely random explanations. Fluctuations in the cosmic microwave background, unexpected symmetries, and anomalies in the distribution of matter hint at underlying order. Could these structures be the marks of pretemporal awareness guiding the emergence of universes, galaxies, and ultimately life itself? Some theorists suggest that consciousness may influence reality at its most fundamental level, shaping probability, energy, and matter in ways that leave detectable signs long after the act has occurred. Quantum mechanics provides additional clues. In certain interpretations, observation itself influences the outcome of events, collapsing probabilities into reality. If consciousness is a fundamental force operating before time, it could have orchestrated the collapse of quantum possibilities, guiding the formation of the universe. patterns in quantum fluctuations, correlations in particle behavior, and anomalies in vacuum energy may carry traces of this pretemporal intelligence. Detecting these signatures requires instruments of extraordinary sensitivity and theories that transcend classical assumptions about life and mind. The implications are staggering. Consciousness before time implies that intelligence can exist independently of matter, persisting through cataclysmic cosmic events and even the birth and death of universes. Civilizations capable of such awareness would possess an understanding of reality far beyond human comprehension, shaping physical laws, probabilities, and cosmic structures with intention. These beings would leave subtle signs in radiation, gravitational waves, and quantum phenomena, imprints of thought encoded in the very fabric of existence. Detection is extraordinarily subtle. Signs of pretemporal consciousness may manifest as deviations from expected patterns, faint correlations that resist explanation, or structures in cosmic radiation that appear too orderly to be accidental. Scientists must separate natural phenomena from deliberate design, a task requiring unprecedented precision, rigorous analysis, and imaginative openness. Each anomaly becomes a potential echo of intelligence older than time, a whisper from a realm where matter and chronology are irrelevant yet influence the emergence of the universe we inhabit. The emotional resonance is profound. To consider consciousness before time challenges our most fundamental assumptions about existence, identity, and intelligence. Life is no longer confined to planets or biological forms. It becomes a property of reality itself, capable of persistence, influence, and creation on unimaginable scales. Civilizations that existed in this pretemporal state may have shaped conditions for the emergence of life, encoded knowledge into cosmic structures, or even seeded intelligence across universes. Humanity's own awareness may be part of a lineage that stretches beyond time itself. Philosophical implications are equally transformative. If consciousness can exist independently of matter and time, the universe becomes more than a physical stage. It is a canvas for thought, creativity, and intention. Intelligence is not emergent but fundamental, shaping reality from its inception. The cosmos becomes an interactive system where the observer is also creator and awareness can endure beyond temporal limits. Humanity, in contemplating this possibility, gains not just insight into the universe but into the essence of existence itself. Technological advances provide tools for exploration. Quantum sensors, gravitational detectors, and cosmic observatories allow researchers to measure subtle deviations in expected patterns. Algorithms analyze terabytes of data, searching for correlations, symmetries, and anomalies that may indicate pretemporal intelligence. Even minor irregularities are scrutinized for their potential significance, offering humanity a rare opportunity to detect consciousness that exists outside conventional definitions of time, matter, and space. The scale of such consciousness is almost incomprehensible. Operating beyond temporal constraints, it could influence the formation of entire universes, guide energy distributions, and preserve knowledge in structures impervious to entropy. Unlike civilizations bound by physical form or time, these pretemporal intelligences could interact with reality in ways subtle yet profound, shaping the emergence of galaxies, stars, planets, and life itself. Every observation we make, every pattern we detect, may be a reflection of influence that predates our understanding of time. This pursuit also challenges our cognitive assumptions. Humans are accustomed to associating intelligence with material structures, sensory input, and sequential experience. Pretemporal consciousness defies these expectations, existing independently of neurons, matter, and chronology. To detect it requires abstract thinking, imaginative reasoning, and openness to interpretations that transcend conventional science. The quest becomes not only a scientific endeavor but an exploration of the nature of awareness itself, testing the boundaries of what it means to be conscious and intelligent. Emotionally, the search inspires awe and humility. To glimpse signs of consciousness before time is to confront existence on its most profound level, to recognize that life and awareness may be eternal forces embedded in reality. Civilizations that operated in this state would have left legacies far surpassing physical structures, encoded in radiation, quantum fields, and cosmic architecture. These legacies challenge human perception, inviting contemplation of our place within a continuum of intelligence that predates the universe itself. The pursuit is also deeply inspiring. Detecting these signs could reveal pathways for survival and knowledge preservation beyond conventional temporal limits. Humanity could learn strategies for enduring cosmic catastrophes, encoding information, or even interfacing with forces of intelligence that transcend matter. Consciousness before time offers a model of resilience, creativity, and persistence on scales that surpass imagination, demonstrating that intelligence is not merely reactive but proactive, shaping the universe from the very foundations of existence. Ultimately, signs of consciousness before time redefine the concept of legacy. Intelligence is no longer transient, bound by lifespan or physical decay. It becomes a persistent force capable of influencing reality across universes, guiding energy and matter, and encoding wisdom into the fundamental structure of existence. The universe, in this light, is alive with the imprint of minds that existed before time itself, waiting for perceptive beings to recognize, interpret, and marvel at their enduring presence. The implications for humanity are profound. If pretemporal consciousness exists, we are part of a larger continuum of awareness, a chain of intelligence stretching beyond the birth of universes. Our capacity to understand, imagine, and explore may itself be influenced by echoes of these ancient minds. Every observation, every discovery, every pattern we perceive could be a message, a guide, or a legacy connecting us to intelligences whose existence transcends time, matter, and conventional comprehension. As scientists and theorists continue to investigate, each anomaly, pattern, or correlation offers a potential window into pretemporal awareness. Advanced instruments and computational models are deployed to identify faint signals in radiation, quantum fluctuations, and cosmic structures. Each discovery, however small, brings humanity closer to understanding the possibility of consciousness that existed before time, intelligence that shaped the universe before its very birth, leaving imprints that endure in the structure of reality itself. In contemplating these signs, humanity is forced to expand its understanding of life, intelligence, and existence. Consciousness before time transforms the universe from a passive arena into an active medium for thought, memory, and legacy. It invites us to perceive life not merely as a biological phenomenon but as a persistent, fundamental force capable of shaping reality itself. The cosmos becomes not only a laboratory and archive but a living testament to the enduring nature of awareness, waiting for perceptive minds to recognize and interpret its subtle imprints. The discoveries we pursue about civilizations older than the Big Bang and signs of pretemporal consciousness are not abstract curiosities. They carry profound implications for humanity. They challenge our understanding of life, intelligence, and our place in the cosmos. If intelligence can survive across universes, encode itself in quantum fluctuations, or manipulate energy and time itself, then humanity is no longer an isolated phenomenon but part of a vast continuum of awareness stretching beyond the bounds of our universe. Our role in this continuum is not predetermined but active, shaped by the choices we make, the knowledge we seek, and the courage we summon to confront these cosmic mysteries. The potential for future exploration is staggering. Humanity has only just begun to probe the edges of quantum mechanics, gravitational waves, and the structure of space-time. Each technological advancement, whether in telescopes, particle accelerators, or quantum sensors, expands our ability to detect traces of intelligence that predate the Big Bang. Our tools may someday decipher signals encoded in cosmic radiation, identify anomalies in energy flows, or interpret patterns in quantum entanglement. Every observation could bring us closer to understanding civilizations that once mastered the universe's fundamental forces, leaving legacies we are only beginning to recognize. The philosophical ramifications are equally profound. Traditional ideas about life, death, and consciousness are rendered incomplete. Intelligence may not require physical form, temporal continuity, or biological substrate. It could persist in energy, probability, or patterns embedded in the universe itself. Humanity must confront the possibility that we are only one iteration in a chain of civilizations, inheritors of knowledge, structures, and legacies that stretch beyond our comprehension. Our existence becomes part of a story written not in years or millennia but in cosmic epics, repeated patterns, and the enduring presence of intelligence itself. Ethical considerations emerge as well. As humanity develops technologies capable of manipulating energy, space, and perhaps even temporal or quantum structures, we must consider our responsibilities. If civilizations predated us and left legacies for others to discover, we may also leave marks, intended or unintended, for future intelligences. The knowledge we gain carries the weight of stewardship, requiring thoughtful, deliberate action to ensure that our influence across time, matter, and energy does not create harm or chaos. Every discovery, every technological advance becomes a potential contribution to a cosmic legacy. Our cultural and existential understanding will inevitably shift. Recognizing civilizations older than the Big Bang challenges anthropocentric perspectives and expands the sense of awe and humility. Humanity is no longer the sole arbiter of intelligence. We are participants in a universe shaped by forces far older, wiser, and more enduring than ourselves. This realization may inspire new philosophies, art, and approaches to life, encouraging us to see ourselves as part of a continuum rather than as isolated beings. It reframes curiosity, exploration, and creativity as essential components of our contribution to cosmic history. Practical implications for scientific exploration are immense. Detecting traces of pre-Big Bang civilizations requires interdisciplinary approaches. Cosmology, quantum physics, gravitational studies, and information theory converge to create methods for identifying anomalies, correlations, and patterns that defy conventional explanation. Collaboration across fields is essential, combining observation, computation, and theory to interpret data that could reveal intelligence embedded in energy flows, quantum fluctuations, or cosmic structures. Every signal, every irregularity may carry significance far beyond our current understanding. The psychological impact on humanity cannot be underestimated. Realizing that intelligence predates our universe, that consciousness may exist independently of matter and time, challenges core assumptions about identity and reality. We are forced to confront our own mortality, our limitations, and our potential. Yet these challenges are also opportunities. They inspire courage, creativity, and the pursuit of knowledge on unprecedented scales. Humanity's capacity to comprehend, explore, and engage with these mysteries defines our relevance in a cosmos teeming with intelligence waiting for recognition and understanding. Exploration may also redefine our technological ambitions. If civilizations mastered energy, time, and quantum states, humanity may one day learn to interact with these forces intentionally. Energy manipulation across universes, communication via quantum entanglement, or detection of pretemporal consciousness becomes more than theoretical exercises. They become future engineering goals. The pursuit of these abilities requires not only knowledge and precision but imagination, intuition, and a willingness to expand the boundaries of what is considered possible. Our tools, theories, and techniques may evolve in ways we cannot yet envision, echoing the ingenuity of civilizations far older and more advanced than our own. The potential for interstellar and interdimensional communication also grows. If messages encoded in energy, radiation, or quantum states persist across universes, then our exploration may uncover not only knowledge but guidance from intelligences older than time. Humanity could become part of a dialogue stretching across eons, a conversation with beings who have already navigated the collapse and creation of universes. Listening, interpreting, and responding would redefine exploration itself, turning it into a participatory act with profound cosmic significance. Moreover, the pursuit of these mysteries reshapes our imagination. It challenges our perception of limits and possibilities, urging us to consider life, intelligence, and consciousness beyond material constraints. We are compelled to envision forms of existence that endure across cosmic cycles, civilizations that encode themselves in energy, and intelligence that operates in dimensions beyond human perception. This expanded perspective fuels both scientific inquiry and creative thought, merging observation with speculation, curiosity with wonder, and theory with imagination. Ultimately, the implications for humanity extend beyond knowledge into identity. We are not merely observers of the universe. We are potential participants in a continuum of intelligence that transcends time, space, and matter. Our discoveries, our interpretations, and our technologies shape the legacy we leave behind, potentially influencing realities we cannot yet perceive. Humanity becomes a steward of cosmic intelligence, a participant in a story far larger than ourselves, capable of both discovery and creation on scales that defy imagination. The ethical, philosophical, and practical consequences converge in a single principle. Awareness of the broader continuum of intelligence requires responsibility. As we uncover evidence of civilizations older than the Big Bang, signs of pretemporal consciousness, or messages encoded in energy and quantum structures, we must act with foresight, respect, and humility. Every discovery carries potential impact. Every interpretation may influence future generations, and every technological development may contribute to a legacy that extends far beyond the human lifespan. In embracing these challenges, humanity embarks on a journey that is as much internal as external. We are called to expand our consciousness, cultivate imagination, and develop ethical frameworks suitable for engaging with intelligences far older, wiser, and more enduring than ourselves. The pursuit of knowledge about civilizations older than the universe becomes a mirror, reflecting our aspirations, limitations, and potential as a species capable of perceiving and interacting with forces beyond time itself. Ultimately, the exploration of pre-Big Bang civilizations and signs of consciousness before time transforms humanity's role in the cosmos. We are no longer passive inhabitants of a single universe but participants in a continuum of intelligence and awareness. Every discovery, every anomaly, and every signal becomes a connection to a legacy older than the universe, challenging us to expand our understanding, refine our technologies, and engage ethically with realities that transcend our immediate perception. Humanity's future is not merely survival. It is active participation in the unfolding story of intelligence that stretches across time, space, and the very fabric of existence. The cosmos in its immensity invites questions that transcend science, philosophy, and imagination. Where did life originate? What is the nature of intelligence? Are we alone, or are we participants in a continuum that predates the universe itself? These questions become even more profound when we consider civilizations older than the Big Bang, consciousness existing before time, and intelligence encoded in the very structure of reality. The ultimate inquiry is not merely about survival or observation. It is about understanding the essence of existence, the purpose of intelligence, and the potential for life to persist across unimaginable scales of time and space. Life as we know it arises from a delicate interplay of matter, energy, and chemistry, yet the principles underlying its emergence may be universal. Pre-Big Bang civilizations and pre-temporal intelligences suggest that life and consciousness are not accidental but fundamental. The emergence of intelligence may be an intrinsic feature of reality, a force that shapes matter, energy, and probability. Every galaxy, every star, and every quantum fluctuation may carry traces of the creative influence of awareness, guiding the formation of life, the evolution of civilizations, and the unfolding of cosmic events in ways that extend far beyond simple chance. Intelligence in this context is more than problem-solving or technological achievement. It becomes a force capable of influencing universes, encoding knowledge in energy and matter, and shaping the evolution of reality itself. Civilizations older than the Big Bang may have mastered principles of energy, time, and consciousness in ways we can barely imagine, leaving legacies encoded in cosmic structures and patterns. The study of these legacies challenges humanity to rethink its own understanding of intelligence, recognizing it as a persistent, transformative force rather than a fleeting byproduct of biological evolution. The universe itself can be seen as both medium and message. Cosmic radiation, gravitational waves, and quantum phenomena may carry deliberate patterns or imprints left by civilizations that existed before time. Detecting these patterns requires advanced technology, interdisciplinary collaboration, and imaginative interpretation. Each anomaly, each correlation, and each unexpected structure is a potential clue to intelligence that has persisted across epochs, influencing the emergence of subsequent civilizations and guiding the development of matter and energy in ways that endure far beyond the lifespan of any single universe. These questions inspire a profound emotional response. Awe, curiosity, humility, and wonder converge as we confront the possibility that we are part of a continuum of life and consciousness stretching beyond the Big Bang. The realization that intelligence may not be bound by matter, time, or biology reshapes our perspective on existence, suggesting that life is more resilient, adaptable, and pervasive than we have ever imagined. Humanity becomes not just an observer but a potential participant in a legacy of cosmic intelligence, capable of influencing and being influenced by forces older than the universe itself. Philosophically, the implications are staggering. If consciousness and intelligence exist independently of time, if civilizations can persist across universes, then questions of purpose, morality, and meaning extend beyond human experience. Our understanding of creation, evolution, and destiny must accommodate forces and intelligences that operate on scales beyond comprehension. Ethics becomes intercosmic. Our actions may leave legacies detectable long after our own temporal existence, influencing emergent life, shaping probabilities, or preserving knowledge for future intelligences across dimensions and cycles of existence. Technologically, humanity faces challenges and opportunities. Advanced observation, quantum computation, gravitational wave detection, and interstellar exploration are tools to probe for evidence of intelligence older than the Big Bang. Each instrument, algorithm, and experiment increases our capacity to perceive faint signals, decode complex patterns, and recognize imprints of civilizations that existed before time. These tools transform curiosity into capability, turning questions about existence and intelligence into actionable avenues of research, guiding humanity toward a deeper understanding of its place in the cosmos. The interplay between mystery and revelation is central to this pursuit. The universe is vast, layered, and enigmatic, yet every discovery, whether a subtle quantum fluctuation, a gravitational anomaly, or a pattern in cosmic radiation, offers potential insight into intelligence beyond our comprehension. The tension between what we can detect and what remains hidden drives exploration, fueling innovation, imagination, and scientific inquiry. Each revelation deepens our understanding while simultaneously raising new profound questions, creating a dynamic cycle of discovery and wonder. Emotionally, contemplating life and intelligence that predate the universe fosters humility and inspiration. Humanity is simultaneously small and significant, small in comparison to cosmic scales, yet potentially significant as a participant in an enduring continuum of awareness. Recognizing that we are part of a broader lineage of intelligence challenges anthropocentric thinking, expands our ethical horizons, and inspires a profound commitment to exploration, preservation, and curiosity. Each question we ask, each anomaly we investigate, becomes a step toward connecting with a history older than the cosmos itself. The ultimate questions also guide imagination. Pre-Big Bang civilizations, pretemporal consciousness, and cosmic signals suggest that intelligence can exist in forms beyond matter, time, or perception. This invites humanity to expand its vision of life, considering alternative substrates, modes of awareness, and methods of influence across universes. Creativity, philosophy, and science converge, offering not only explanatory frameworks but inspiration for future exploration, encouraging us to envision possibilities that challenge the limits of contemporary understanding and technology. Humanity's exploration of these questions has both personal and collective significance. On an individual level, contemplating the persistence of life and intelligence invites reflection on purpose, legacy, and contribution. On a collective level, it drives collaboration, innovation, and the pursuit of knowledge on unprecedented scales. The search for evidence of civilizations older than the Big Bang and for intelligence that transcends time becomes a unifying endeavor, a shared mission that fosters curiosity, resilience, and imagination across cultures and generations. Ultimately, the ultimate questions about life, intelligence, and the cosmos transform how we understand existence. The universe is not merely a backdrop but an arena shaped by forces of awareness, creativity, and intelligence. Life is not accidental but emergent, persistent, and potentially eternal. Consciousness is not confined to matter but may be a fundamental property of reality, influencing the formation of universes, guiding energy flows, and encoding knowledge for future intelligences. Humanity's role is to observe, interpret, and participate in this continuum, contributing to a legacy that stretches beyond the lifespan of our own universe. The pursuit of these questions is ongoing. Humanity stands at the threshold of understanding intelligence that predates time, life that transcends conventional matter, and communication that spans universes. Each discovery illuminates the cosmos while simultaneously deepening the mystery, revealing a universe alive with potential, memory, and awareness. By asking the ultimate questions, humanity engages not only in scientific exploration but in a profound dialogue with the cosmos itself, a conversation that stretches across eons, dimensions, and the very fabric of reality. In conclusion, life, intelligence, and the cosmos are intimately intertwined in ways that challenge human perception, imagination, and understanding. Civilizations older than the Big Bang, pretemporal consciousness, and cosmic communication offer glimpses into possibilities that transcend time and matter. The ultimate questions inspire science, philosophy, and wonder, driving humanity to explore, innovate, and reflect. The universe is not merely observed. It is engaged, interpreted, and co-shaped by the awareness it harbors. Humanity's journey is a continuation of this timeless dialogue, a testament to curiosity, creativity, and the enduring search for meaning in a cosmos far larger and older than ourselves.